denial, AD, is denial of enemy's freedom of action in areas under friendly control. It employs more defensive means such as air and sea defense systems. As modern military technology is required to uphold A2AD, it is almost exclusively practiced by advanced regional powers such as Russia and China. Recently, China has emerged as an assertive regional power in the Asia-Pacific with forceful A2AD capabilities, using advanced ballistic and cruise missiles in conjunction with air and maritime defense systems to deter its adversaries in the region. The Pentagon's annual report on China's military strength from 2019 describes the A2AD strategy as a means to dissuade, deter, or if required, defeat third-party intervention against a large-scale theater-wide campaign mounted by China's People Liberation Army. In short, it appears that Beijing's aim is to prevent American and allied military forces from operating freely in the A2AD airspace and maritime bubble around China's coastline. China has in recent years worked to extend the range of this bubble beyond the so-called First Island chain and into the Western Pacific. The key to this effort is not just long-range missiles, but also a growing number of space-based sensors. The US-based Union of Concerned Scientists reported as of 2016, China has 192 satellites in orbit, a number that has only increased since then, with nearly all of these belonging to organizations to ultimately generate a targeting approach. With this introduction, I would like to begin the session for today. Over to you.
Thank you very much once again, and I think you have to be bored by me for the next at least half an hour. And my apologies for kind of trying to keep on pushing this angle about how well China has done in the space domain. So today I'm going to talk a little bit about the space part of what I think they'll do. Everybody see it? It's readable? Yeah. So, I mean, I've tried to make the font big, but sometimes it gets a little smaller because you always have more to say than what you can show. The problem with all academics is they keep talking and talking and talking. They don't do anything. So I will talk a little bit about what the space part of China's anti-access area denial strategy. In the morning, in the introduction, I told you about our interest in the fact that, this anti-ship ballistic missile, now that has to target a lot of aircraft carriers or any other naval asset that is approaching Taiwan from all the seas that are surrounding. I'll show you a picture so that you get a better idea of the geography. Obviously, you have to locate something in a very large area. The ocean is a huge area. A ship is a relative, even an aircraft carrier with all its assortment of accompanying quite distributed. It's kind of difficult to locate. It's like locating a needle in a haystack thing. And therefore, one of the problems in you have to be able to locate it. And not only must you be able to locate it, you must be able to keep track of where it is, because the problem of any conflict arising is a dynamic kind of thing. So while there are certain predictors about when it can happen, you really don't know whether it will happen or not, and therefore you need to keep tabs on the particular target that you have in mind. So these are the two kinds of problems that a typical anti-access area strategy needs to address. And I will talk about how China has kind of over the years created a very robust capability, and I will present some details about how they could be doing it. Okay? So that's really the kind of thing that I want to focus on today. And please feel free to interrupt and ask anything that you feel is important. I mean, if there's any doubt that you have, we can clarify. And of course, I hope, have a big question and answer session where we. Okay. Can I have the first slide, please? Yeah. Now, we all know what happened in August 2nd, 3rd, 4th, 5th, I mean, the first week. We had all this major confrontation over Taiwan. I think Nancy Pelosi visited Taiwan and the Chinese wanted to make a point, and therefore they did a lot of things. They carried out a lot of exercises and maneuvers. This is a very well what I call thought out a picture that was put out by CSIS, right, in a journal called China Power, and it tells you where all the exercises areas were, where the Chinese actually conducted military exercises, and you can see that it is surrounding all of Taiwan, and it is also looking at all the major military targets. The air bases are covered, the naval bases and the ports are covered, and some of the exercises are also covered in areas which are called disputed areas. They're disputed areas of the EEZ, for example. So the Chinese are making a very clear demonstration of what they can do. They want to show all the neighboring countries as well as the US, this is what we can do. Okay, so it's like they are projecting their ability to respond to a crisis over Taiwan. Okay, so that's really what they're trying to do. And if you see the dotted line, now in 1995-96, there was a similar confrontation between China and the United States. And in that confrontation, what happened was they fired some missiles, but that was largely along those two islands called the Matsu Islands and the Kinmen Islands. And you can see the dotted line where we talk about one. That was the extent of what they could actually do at that time. Okay. Now, since that time, you can see that they are now able to precisely do all kinds of exercises, integrated exercises, around the whole of Taiwan, and it covers almost all the sensitive military installations that Taiwan has in mind. So it does mean that between 95-96, when the third Taiwan crisis happened, and 2022, when the fourth Taiwan crisis happened, they have moved forward significantly. Now, if you go back in history, I mean, some of you might want to look at that also. There was a Korean crisis, a crisis in the Korean Peninsula in the 50s, where the Korean War was fought. At that time, Taiwan was also in the middle of a lot of the issues, right? And then there was a second Taiwan crisis and first Taiwan crisis and a second Taiwan crisis again in the late 50s, where once again the US prevailed by sending 2 aircraft carriers or a few aircraft carriers to that part of the ocean. The same thing happened in 1995-96. So one of the reasons why the Chinese are paranoid about the anti-ship ballistic missile and making it happen is because they are always worried that the projection of naval power, historically naval power, has created a lot of problems for China, and it continues to do. So in a sense, you can argue that the entire response of the PRC and the PLA is about responding to this naval threat. Can I have the next slide, please? Yeah. Now, apart from the exercises, there were also a number of ballistic missile launches that they kind of put out. And these are some of the targets that they are looking at. And there are a number of locations, mobile locations. They can move around most of these things from where they can launch. And it can come from all kinds of directions, making it difficult to defend against. Okay, so all these things are there, and you can see that once again they have targeted quite a lot of the areas in around Taiwan. Okay, so not only do they do the exercises, but they also have this precision strike capability that enables them to pick out a ship or something on the sea to be able to hit it. So this is the other thing that was quite clear from the exercises carried out. So the next slide, please. Yeah. Now, I had made an earlier presentation to C3S, right? And I had looked at the vulnerabilities of China. So why is China so paranoid about all this? And why is it actually creating all these capabilities? Obviously, it has concerns, and most of these concerns are about its neighborhood. So China has got about 14 land boundaries with different countries. And this just tells you the kind of problems that they have. So you have Russia, North Korea, Cambodia, what I would call the Korean Peninsula, the Indochina Peninsula. You're looking at India, you're looking at the Central Asia, and of course you're looking at the earlier enemy, now turned friend, Russia, or the Soviet Union earlier. So you have, these are the kinds of threats that it is facing on its land. And of course, what happened in the 90s when the Soviet Union broke up is that the major threat that they thought was from the Soviet Union had actually now become a little bit more comfortable for them. And you can therefore look at a ranking of all these vulnerabilities from the basis of this. I've just put down one ranking that I think was the right ranking. You could come up with other ways of doing it. So this is the land side of China's vulnerability. Have the next slide, please. But you must also remember that China has a lot of ocean areas, and a lot of the threats in the last 150 years have always come from the sea, especially from the British, US, Japan, imperial navies, and the 100 years of humiliation that China went through. All of it has a significant naval domination by the Western countries. Okay. And one would therefore argue, and Taiwan, seceded in a sense from what the PRC thinks is its own country when the People's Republic was formed in 1949. So you therefore feel, so you can actually look at the threats that from the sea, which seem to be the major threats. So Taiwan is obviously the number one threat, and that is one. Korean Peninsula is number two, close to number two. There's a war that fought. The Indochina Peninsula, including Vietnam, there's another war which China fought with Vietnam, so that's also another major area of concern. The US base at Guam is not too far away. So you can actually see that these are the kinds of threats, and the threat from the sea is significantly greater than the threat from the land, is the way I would look at the way we have to look at all of that. So we can now look at a kind of combined land and sea based kind of thing that China has to contend with. Can I have the next slide, please? So one could therefore rank the threats in some form. Taiwan is obviously the most important part, and the Chinese think it is a part of them. There is a historical basis, though Taiwan has been with China only for about 300 or 400 years. Guam, the US base, is a major problem because it has a large, military base. Japan has always been a threat. If you go back and look at the history of China, Japan and Chinese problems have been a major role in the 100 years of humiliation that China went through. The Korean Peninsula, China has dominated it. The Korean Peninsula has kind of reacted. So it's also another Indochina, Vietnam. So these represent, in my opinion, the major threats. And as you can see, most of the threats have a significant naval or a sea component, and therefore the Navy and the sea part of China's anti-access area denial strategy is kind of important. So the threats are likely to come largely from the sea. Therefore, you have to make sure that you can deal with these threats in the proper way. This is really the background within which we need to look at the A2AD strategy that I'm talking about. Can I go to the next slide, please? Okay, I'm sure all of you know the first island chain, right? This is the immediate threat in the immediate part of China's neighborhood, and obviously it doesn't want anybody coming into this island chain. And then you have what is called the second island chain, which also encompasses the US base at Guam. You want to make sure that in this area also, you don't want any hostile forces. So ideally, you would want any hostile force to be dealt with outside these two island chains. So you want to target things that are far away. You can see relatively by these distances, you want to target things that are far away from the coastline of China. And obviously, if you want to target and identify objects beyond that coastline, you need to be able to look over the horizon. And if you want to be able to look over the horizon in a foolproof manner, you need a significant number of satellites, okay? And that is the reason why satellites and space has become very important as a part of this A2AD strategy for the PRC, okay? Now the next slide, please. And how do they reach these targets? Now, obviously, one way is to have an aircraft carrier that can go all over the place and project the air power through the aircraft carrier. Chinese don't have that many aircraft carriers. The Pacific Ocean is very big, and it may take a long time for them to be able to do that. The other alternative to replace an aircraft with a precision strike missile, and you can see that the Chinese have a whole range of missiles which are dedicated to this, okay? And increasingly, these missiles are becoming more and more accurate, so they can actually precisely hit target, okay? And in order to be able to precisely hit the target, they also have to know roughly where the target is located. So there's a lot of autonomous capability in these missiles, And once they know the broad area or a limited area within which they can look for the target, it can go search for the target and actually hit the target. Those are the kinds of capabilities that we can actually do. Now, originally, when you look at the missile mix, a large number of them were nuclear focused. But today, I think the significant number of missiles are conventional missiles. They are either ballistic missiles or cruise missiles. So they operate functionally differently, and the combination can be very lethal. Okay, so both have advantages, and some of them have a few disadvantages. But in combination, they can provide a lethal force. And as the precision accuracy increases, they will be able to target more and more accurately, right? So an aircraft carrier is a very large vessel, okay? Can be identified fairly easily. And once you know where it is, it can also be hit fairly easily, okay? So that's the kind of thing that we're talking about. Okay? The conventional missiles are now the dominant thing. They are the fastest growing part of the missile arsenal. So while the nuclear missiles are also getting modernized, the relative pace of modernization and improvements is more on the conventional side and less on the nuclear side, as would, because once you have a nuclear deterrence, it doesn't really matter how many numbers you have. Although China is also increasing those. Can I have the next slide, please? The other part is, do you have the organizational capability to be able to carry out those exercises? So in 2015, China decided that it would break away from the conventional organization of the military in terms of the army, the navy, right, the air force, and also they had a special artillery force that looked at the missile part. And they decided that rather than looking at it in terms of the functionality, they would go with theaters. So they established 5 theaters: the Eastern Theater, Southern, Western, Northern, and Central theaters. And therefore, the theater guys, the theater commander, became the paramount, what I call, authority for war fighting in that particular theater, right? So the army, the navy, and the air force, and the rocket force, and other part of it, all had to come under the purview of the theater commander, in a sense. Okay? Now, this involves a significant reorganization of the military, and it's not easy to bring about some of these organizational changes. So that was one major thing that the PRC created under G, of course. And they also created this other thing called the Strategic Support Force, if you look at the top, which dealt with the space part, which is like a common requirement for all theaters. And there's also this information requirement. Space is a part of the information requirement, because collecting the information through surveillance satellites, also moving it around through all kinds of satellites at medium, low Earth, and geosynchronous orbit, as well as, in my opinion, the cyber part, because satellites use a number of microprocessors, and a lot of it is data-based and control-based data, digital data control. So once again, all of that is very important for war fighting. And so they created this special force called the Strategic Support Force that kind of gives them the organizational tools along with the theaters to kind of fight and win, right? I talked about it earlier, local wars under conditions of informationalization, which is what they see. So they see a Taiwan crisis as a local war. That's really the perspective with which they are looking at. Now the next slide, please. This is just to give you an idea of the theater commands. I think everybody must have seen this slide. I'm sure a lot of you have studied it. Can I go to the next one, please? So the point is, all this part therefore reveals that China has not only taken the necessary steps and to do all this. So how does the space part of what they're doing play a role in this anti-access area denial strategy? I think as of 2020, when this book had kind of finished, China had what's called 68 Yagon satellites, okay? And about 40 of them were operational. About 20 of them had kind of finished their life and were kind of not in functioning order. Most of them are dedicated for what I would call the intelligence, surveillance, and reconnaissance function. Okay. Now, basically, what does it mean? It means that they collect data. They try to locate objects within that thing. So this is mainly what I would call a remote sensing satellite, or imaging satellite, or a synthetic aperture satellite, or if they collect electronic intelligence, they are electronic intelligence satellites. Okay? And so what we did at NIAS was to look at all of them and then try to categorize them. There's a whole lot of approaches that we can do to categorize them, and they are fairly easy to do. They're not very difficult to identify. And we can actually, from the way the orbits are, the kind of perigee, apogee, the altitude, the launch vehicle, the mass of the satellite, we can make and that what I would call the launch time, we can come up with a number of open source parameters by means of which we can actually fix, okay, the kind of satellite that a particular Yagon satellite associated. And our work at NIAS showed there are two types of electronic intelligence. They also have two types of electro-optical sensors, and they have a synthetic aperture radar capability. And so what can they do with this constellation? So for example, you want to look at a particular point on the Earth, for example, Taiwan during the crisis, we can actually select these satellites, right? Understand their functioning, and then be able to find out from them, right, what part of the time looking at would a target like Taiwan be covered by, right? So this exercise is something that it was possible to do, and we did it because we had a special software package that was developed by my colleague Dr. Raman, okay? And I will tell you a little bit about the results of this exercise. But before that, I have to tell you a little bit about the nature of the satellites and the kind of coverage. Can I have the next slide, please? Okay, now, as I said, when we were doing the ASBM, when the problem of the anti-ship ballistic missile was first referred to us, we wanted to know whether the Chinese could actually locate an emitter, electronic emission source in the Pacific Ocean. Now, the first of the requirement to do that is what is called the Yagon triplets kind of satellite. So this is a 3-satellite constellation that is in a triangular that flies in a triangular formation. The distance between the 3 satellites is very well known. Okay, they put the satellite in a very special kind of inclination, 63.4 degrees, and that inclination is chosen for a particular purpose. A satellite in a 63.4 degree inclination will not precess at all. What does it mean? It means that the satellite perigee and the apogee, which are the 2 extreme points of the satellite, are likely to rotate time. If you put it in a 63.4 degree orbit, it means that they will not rotate at all. The rotation, the precision rate, and the Earth's precision rate and the impact of the orbit itself will make sure that the perigee and the apogee will always be at the same fixed location in the orbital plane. Okay, so this is it. So if you have 3 satellites and the position between them is known precisely, those positions are not likely to change if you put it in this kind of an orbit. The practical implication is that. Okay, so if you see 3 satellites put together in orbit in a 63.4 degree inclination, you have a dead giveaway that this is a electronic intelligence triplet, right? And what does the triplet do? If you have an aircraft carrier that is emitting radio signals in the Pacific Ocean, it can locate it within a certain range, say 25 kilometer CEP or a circular error problem. So it can locate it. So instead of looking at some 7,000, 11,000 kilometers, you can narrow down to about 25 kilometer radius circle, right? Which is a significant advantage. You don't have to look at the whole of the Pacific Ocean. You can look at the part that you think where the particular object or target. So that is the advantage of this kind of orbit. Okay. So we did this exercise, and currently China has this, they are calling them the Yagon 31 series. They have 12 of these satellites. So they have 12 operational satellites. They are distributed in different planes. I'll talk to you a little bit about that. So this is one of the requirement. So you see that small blue circle on the right. So within that larger circle, I can locate a particular emitter to a smaller degree of uncertainty. It's very, I can locate it fairly okay, right? To enable me to target it a little bit better, right? That's the purpose of this. Can I have the next slide, please? Now, that by itself is not enough because you don't get continuous coverage, right? And what happens, why do you need continuous coverage? If it's far off, beyond the second island chain, I don't need to track it so often. But as it comes closer to my shoreline, right, I need to keep tabs on it much and much more, right? I need to know where it is continuously. In order to do that, they launched a second series of electronic intelligence satellites. Now, those are not in the triangular formation. They are all in the same orbital plane. I will show you the geometry a little bit. So these are at different inclinations. They are at 35 degrees inclination. And they are orbiting at about 610 kilometers. Okay? And they have 18 satellites in this configuration. And the coverage circle is about 10,500. Right? Here, you don't know the location of the emitter. But if you know the location of the emitter from the earlier satellite, then you can locate this emitter also within this larger circle. So this is the kind of logic that they are building. So the 12 satellites that they have earlier and the 18 satellites that they have now together will be able to continuously keep track, right, about the emission of any radio things that are happening in the vast reaches of the Pacific Ocean. Okay. We understand that? Is it clear? Yeah. Okay. Can I have the next slide, please? Yeah. So just to give you an idea of the tactical thing, so the Earth, you can see, is got 360 degrees. What you have is, you have three different planes, orbital. Satellite is going over Earth. If I am at 0 degrees, one constellation at 0 degrees longitude. So the constellation is going at 120. When the Earth rotates, so when the Earth rotates, right? So one satellite series is going to be seeing a particular target. As the Earth rotates, the next plane will come and the next series of satellites will see the target. And then there's a third plane that will rotate after the Earth rotates even further. And after the Earth rotates a little further, the first plane will come back. So you have these planes that are different locations that cross the equator at different. So you can see that one location is 120 degrees, separated by another 120, the third 120. So 360 degrees, you can have three planes of orbits. In each plane, there are 6 satellites. Together, they make 18 satellites. And as the Earth rotates, one plane is replaced by another plane is replaced by Earth. And along with the triplets that I talked about, they will enable us to keep continuous tabs in the Pacific Ocean. So this is the logic or the architecture of the Argon satellites. So there are a total of 18 satellites. And I think the last data I have is they are not even 3 planes, they are something like 4 or 5 planes. So they're kind of optimized it. One has to do more detailed studies. So so you can actually see the separation across the globe. So and as the Earth rotates, one plane will go, another plane will come. They will continuously be able to track the target. Have the next slide, please. Okay, just to give you the idea of the geometry, in each plane there are 6 satellites, and you can see they are separated by 60. As one satellite goes over the horizon, the other satellite will rise, and it will. So 6 satellites in sequence cover the area, one after the other. And as the Earth rotates, the next plane, which also has 6 satellites, then take over. So this is how it works. Just to give you an idea that this is the geometry of the architecture that they have. Can I have the next slide? And along with this, they also have these imaging satellites. They have 2 types of satellites. One are in 1200 kilometer orbit, which gives them about 1000 kilometer. Now, optical sensors can be moved. They have a field of view which is about 60 kilometers. But because you can move the camera, it will actually cover 1000 kilometers. So if you know an object to be located somewhere within that 1000 kilometers, I can actually more precisely get a picture. Once I get a picture, I can locate the object, accuracy of a few meters. So from kilometers with an optical imaging satellite, I can reduce the inaccuracy significantly. So that is the purpose of the optical imaging satellite. So they are in 2 orbits, and one is in 600 kilometer sun synchronous orbit, the other is in 1200 kilometer sun synchronous orbit. These can again be identified using the standard stuff that I talked about. You can categorize all of them, and we can derive these things fairly easily. Have the next slide, please. Okay, now star satellites are slightly more complicated. Our SAR satellite can look only at one side, okay? Which means that if the satellite is going like this, it can look at this side, it cannot look at this side. If it looks at this side, it cannot look at this side, okay? And the area beneath the satellite thing itself, it cannot see. It can only see a stretch to the side of the satellite. So the modeling of the sensor is a little more complicated. So this just to tell you that this also has to be kind of captured in the analysis that we. And so you can actually the 1,000 kilometers directly below it may not be seen. You will have to move it around on that, and that's the kind of swath that we can get. So we have all the details of all. So all this stuff that you are talking about, the sensor parameters are based upon publicly known information, and a lot of it is publicly known. We all know this. Many of us have been involved in a lot of it. So I think there is a reasonable accuracy with which we can model the sensors on these Yagon satellites. So can we go to the next slide? Okay, now I have to tell you a little bit about the software. My colleague Ramani developed this software called the Veni Vedi Vici software, right? And we can therefore take stock. I told you Taiwan. We can actually find out the coverage of Taiwan during the crisis by using this constellation of satellites. The software enables us to do that. Now, how does it work? It uses the orbital information that NORAD, the North American Air Defense Command, they put out these things on all satellites. All the Argon satellites, the data is available. What Ramani's software does is it takes the data, and we can then look at the orbit, how the orbit will move for the next few days. And we can actually make a prediction as to where the satellite will be at what time. So that part is. So this is fairly easy, and Ramani has been dealing with it in ISRO for a long time. But we had to do some changes. He will, if required, we can talk about it. Okay, right, so this is one part. The other part that this package does is, we also model the sensor that the satellite will carry. As I said, from the orbital data, we can find out what kind of a satellite it is, and we can know the sensor, right? I showed you the coverage of those sensors, the ELINT sensor, the triangular ELINT sensor. I showed you the optical imaging, the SAR imaging. I showed you the architecture. If you put all of that together, right, we can actually get a good idea of the coverage. So what we can also do is, you can specify any part on the world, right? Any target. It can be a point target or an area target, and we can find out how much coverage of that is obtained through this satellite constellation that we have taken. So we will look at a problem that is looking at Taiwan between August 4th and August 5th for it. And in our run that I'm going to show you, we have only used the 12 broad area ELINT satellites, which give you the location information, and the 18 tactical ELINT satellites that keep tabs on the constellation. And we will look at the results of this study in the next. Can I have the next? So now what we did is, we looked at Taiwan for a period of 24 hours, between August 4th at 4 hours to August 5th, right? 0 hours, sorry, 12 midnight to 12 midnight. And so we can see that, so the first is the satellite. The first column is the satellite number that we are talking about. The second time is from the start of the simulation or the projection, how much time has elapsed. And the second column tells you how much time the target is covered. So the first Yagon 30Z, within the first 3 seconds of the start of our exercise, the target has been observed for 2 minutes. That means 2 out of 3 times it has been 2/3 efficiency it has achieved in the first 3 minutes. So if you go to the 4th minute, it has shown 3 minutes. So the efficiency increases to about 75%, right? So you do that. So if you look at a number like 101 minutes elapsed time, you get the coverage time of 83 minutes, and the efficiency is about 82.17. Right? And as you can see, within a very short time of about 2 hours or 3 hours, we get to an efficiency of about 88%. So the number comes to about, so in other words, a target is visible for about 90% of the time, 88% of the time over this period. So this is something that I think very useful. Now the other part we can do is we can also get the details about how much time there is a gap, right? If the gap periods are very long, then we have a problem. But if the gap periods are going to be less than a few minutes, right, we have no problem. Because within that, the target could not have moved, it will be approximately the same. So these are some of the things that we can actually do with this kind of approach. All ships, any ship. The stealth ship does not emit electronic, any electronic emission. If you shut down the electronic emissions of an aircraft carrier, I'm not sure it's functional. Effectively, you shut it off. Without emissions, it cannot survive. I mean, it cannot do its job. I don't think survive is the right. In other words, yeah, we can do all that. But without emission, aircraft carrier cannot do it. All of that is there. All of it is action. All of it is possible. So what I would like to argue is all of these possibilities and the action-reaction approaches that one can take have to have a baseline on which you can play all these scenarios. I would argue that this is the baseline on which we must impose all those conditions. Then look at how do you do those conditions. In other words, the first step in a game-playing exercise. But this is the first step. I mean, you can question the value of the first step, but without this first step, you can't even go to the second. You can't even think about this. So I don't want to go into tactics. I'm not an expert in all. But I definitely know that if you don't have this baseline, you can't really look at any kind of approach to dealing with them. I mean, that's really the point I want. So I think all those things, countermeasures, non-countermeasures, so what I would call action, reaction, action, reaction, action, go to 5, 6 order, 7 order, you can go on playing these games. The argument is you need to start somewhere, and the first step that you need to know. So frequency hopping is certainly a possibility. Standard. Encryption is another possibility. There are other things, spread spectrum. So there's a whole lot of. Okay, can I have the next slide, please? So I just show you the typical run for the whole day, and you can see we have efficiencies of the order of 88 or 89%. But more than that, we have to worry also about the gap. If the gaps are not too large, I would say less than 5 or 6 minutes. So we did an exercise to gap, although I don't have the data here, but it looks like the gaps are very minimal. Most of them are between 5 and 8 minutes. So one would argue that it's not only that 88 or 89% efficiency, it is very difficult for an emitting target to lose. The Chinese will be able to keep tabs on any emission, right, that is coming in accessing towards type. Okay, that is the conclusion that I can say. Now in this exercise, I've not included the coverage of the optical and the SAR satellites. The moment that comes, the location accuracy will become much better. So the next exercise we will do is to bring that in also and get a better number. So we need to look at the distribution of the gaps. We also need to look at bringing in those satellites, then looking at them. But it will be very difficult, according to me, to escape surveillance by the Chinese satellites. Okay, I think this is pretty clear from the architecture. So the Chinese are just not talking, they are actually demonstrating it. It's been operational now, I would argue more than 5 years they have this complement. And they are likely to keep changing it a little bit. We need to understand those changes. That is right. Can I have the next slide, please? So how does it work? Just to recap, the large area ELINT can locate the emission source within an area, say 25 kilometers CEP. This is a number I'm not sure about, just a number I put, okay? But it will help. We need to do a little bit more technical work. We are not equipped to do it. We can actually get a better handle on location with some expert. But I don't think we can do it with the resources we have at NIAS. We cannot do it. This will help locate the same emitter by the tactical ELINT, and it can keep tabs on it. If the area falls within an optical or a SAR sensor, then its location would be determined with an accuracy which is of the order of a few meters. You can determine it much more precisely. We have also looked at the gaps in coverage. The results show that the gaps are mostly of the order of a few minutes. So it's more or less continuous. Okay. It therefore appears that the right kind of queuing, the movement of a ship can be continuously tracked. The information transmission to various entities may also involve communication satellites in GSO, and they are tracking and data relay satellites also in GSO. Both of them, China has them, and they will use them. It has also helped, right? There are a number of other elements that have to work together in order to make this strategy real. It's not only about satellites. You need submarines, you need frigates, you need all the navy, you need drones, you need aircraft carriers, you need the army maybe in some locations, right? You need air force of various kinds. You need missiles of different ranges, different platforms from which you can launch them. So it's a whole complex array of all kinds of integrated components that have to be put together. This does not address them. You have to look at them separately. I have another study that I've done, which I will not talk about here, but we can actually build on that and kind of do more detailed, integrated kind of approach to what approach should be. Can I have the next one, please? So I would come back to the slide I showed earlier. I think China has in place all the space components that it requires. They have one thing that is not missing. They have what's called an early warning satellite, which is a geostationary orbit that can pick up the launch. Now, I think from the data that I've seen in 2019 and 2020, more or less one can argue that they are experimenting with that. I would expect that that gap will also be soon filled. I think they have it, but it may not yet be operational. Red. And so they have something like a, what I call, they call it a staring camera, which means that it is it's looking at a part of the world, and anything that goes about 10 kilometers that has a temperature signature can be. And if they can track it a little bit, they can actually predict where it is. That's what the Americans have had for a very long time. So I think they are there also, but we are not sure yet. I would argue from whatever data I've seen, that is there. Of course, as I pointed out, they are putting all of this together. There's an integration organization in place that takes care of all of it. Operations command, all of this, all these components that they have in place. So this part, I tend to believe, the space part and its correct connection with the access denial is very much clear and evident in the Chinese space program. Can I have the next slide, please? So just to come back to, so the Chinese are looking at space as a part of a larger power projection. So the civilian use and the military use are well connected, and there is an increasing integration between the civilian and the military function. So if the military has a problem, there's a backup civilian option available, and the Chinese are kind of strengthening these connections. They have an arsenal of missiles, as I pointed out. They have a very strong economic agenda. Just to give you a point from the book, they have sold, see, the Americans put an embargo against China, which prevented any satellite launching by China, which meant that if any satellite carries an American component, the US State Department will not give a license. Okay? Which meant that the satellite, if it was to fly on a Chinese launcher, would not be allowed to fly. Now, the Chinese have lost quite a lot of launch opportunities because of that. So their workaround plan was to completely indigenize the production of satellites without any American component. Okay? So they went and collaborated with a number of European companies, and they've come up with a number of satellites which they have used domestically, which they produce domestically. And now what they do is, instead of buying a launch, you buy the delivery of a Chinese-built satellite in geostationary. So it's kind of bypasses. And most of those satellites do not have any American parts. Therefore, sanctions work. At least that's what I think. This is, so the Chinese have exported satellites to Nigeria, Pakistan, I think Bolivia, number of countries, all of them are listed, Laos, Belarus, okay. So they have about 13 satellites. Saudi Arabia also, I think, or they have a kind of built and the remote sensing satellites also they are building and delivering. So they are taking care of that. So there's also the economic agenda. Then of course, coming back to this part I talked about. So in the conventional war, right? In the earlier days, we looked at nuclear weapons and conventional weapons. We now have to go beyond that. We have to not only look at nuclear weapons and conventional weapons, we also have to look at space and space-related weapons. We have to look at cyber-related weapons. And the platforms can be land, sea, air, underwater, right? I don't know, the intermediate region between space and the atmosphere. A whole lot of dimensions are changing. Of course, the geography is now the world, and geography is also going to be a part. So it's going to be a different domain and a different kind of thing. And so as I pointed out in the last presentation, right, the US domination of the IT battle space, the only counter that the world has to offer today is China. And therefore, this new dynamic between the US and China is actually going to drive a lot of what's going to happen, not only on the military side, but definitely on the space part. Any more slides left? Let's check. Over? So the point I want to make is that the A2AD, the space part of A2AD, is operational. And in my opinion, it's a significant enhancement Chinese military powers for engagements in the ocean areas of the world. Okay. But I would argue that China is not really interested in all of the ocean. It is more interested in the Indo-Pacific part of the ocean. And in that area, I tend to believe they have become very strong since the earlier Taiwan crisis. And I think that strength is likely to continue to grow. And the US, unfortunately, is a global power, so its resources are distributed across the world. And I think concentration of Chinese power in this part of the world will definitely stretch, right, US resources, right? And it's also going to result in a significant economic cost to the US. The economic cost to the US is much more than to China, for example. So it's going to be a different kind of problem, right? I think the US systems are engaged with it and they have different approaches to looking at it. But one part of the US strategy in this part of the world has to be an alliance-based approach, right? So the allies are going to become extremely crucial in this fight for the Indo-Pacific part of domination. I would like to end here, and any questions, welcome. I can stand. I don't used to like. What will be so.
So this is Bala from C3S. Thank you for the insightful presentation. I have two questions. One is regarding the Beito, the NavSat system of China. So correct me if I'm wrong. They have a unique system where it has a SMS provision. So can we infer that China now can influence operations through SMS? Why do you think now it is being provided? Point number one. Just 1 second. I'll just go for the second question. And when reading through the literature, what I got to know is that China is very much interested in the pulsar X-ray based navigation system. So why is China is very much showing interest in this? Thank you, sir.
Okay, so let me answer the. See, once you have a communication capability, use it in any form you want. What does it matter? SMS, any other form you want. I think the bulk of the problem I think we should move away from. See, we see communication satellites as one important resource, right? US doesn't see it like that, for example. It's in the link, right? They're worried about how to get it to the guy in the field, right? I don't know whether you've seen the drone operations and all that, or the Osama bin Laden operation. You can see that they are actually connected to anything that happens anywhere in the world. It's simply because of the satellite system. So Viasat, their communication satellite, which I think has a throughput of, I remember reading 100 gigabits or something. The Chinese are about 20, okay, and we are at about 10 or 15. So the point I'm making is satellite communication capacity that carries the information from the sensor, right? You're sensing something. You want to make sure that it reaches all the people. So in other words, you want to take the data and process it through the entire network so that whoever wants to get it is able to get it. So we should think of the communication as an essential part, right? And maybe the more important part of an information. So you are looking at it purely SMS. What is SMS? What is anything? It is a map, terrain map, a location map, or you want to know where the enemy things are located in real time or near real time. It takes a few microseconds to go and come down. It should be available to the guy on the field. My argument, the Chinese are thinking. So they have only 9 dedicated military satellites. Okay? Communication. They have 4 TDRS satellites. 5 now. So they have at least 14 or 15 dedicated communication satellites. They have a fairly big civilian capacity. So some of this traffic can also go through the civilian thing. So what is SMS? Anything else, anything that you want should be available. That should be the motto. They're always looking at satellite communication, the constraint. They're talking of one side. I think we should have 20 communication satellites dedicated to them. Why can't we do it? We can do it. We should think differently. My point is, in an information war, if you don't have the ability to move around information, you are lost. Right? It doesn't have to do with the bravery of our army and navy. It's fundamental technical capability that is minimal in a war, in a modern war. We must do it. So this is the first one. So the reason why the Chinese are interested in a pulsar thing, there are 2 reasons. See, one is the purely scientific, what shall we say, accolade that you get because you are the first in the world to do something. Now, the Chinese are particularly interested in the political mileage that they get out of their space activity. So I would argue that all the planetary exploration program, the moon missions, right? What I call the famous, what I call quantum satellite, all of that are kind of firsts. The Chinese want to tick that box because it does definitely give them major political advantage. So that is one. Second part, which is actually very functional. Pulsars time, the rotation rate and the timing of the signals is very, very precise. So if you have a number of pulsars and you have the timing information associated, it's like a natural made atomic clock. Okay? So you can use that time. See, here you have GPS on the ground, but if you go into, I don't know, moon or interstellar space, right, you need another timing device, right? It's possible that you can use it even on the Earth. So maybe it's an alternative to the GPS. They are looking at it. So the other part, in my opinion, function. Gives you very precise time information, which we can use for navigation. Both of them. So it's got an applied purpose, it's got a political.
My name is Vivek. I am from Defense and Strategic Studies University of Madras. Sir, my question is that A2AD strategy of China. US started US launched a counter operations for it is known as especially China Sea. It is focused on China Sea. How can it be? There are any loops to maintain his counter it?
So let me come back to this question, right? So what is the problem? One of the problems is going to be how far can you come into, right, the seas of China. So I talked about the first island chain and the second island chain. Now, one of the problems that the US had earlier, right, was that they had signed a treaty called the Intermediate, Intermediate Nuclear Weapon, all the intermediate range missiles, right, were not to be developed either by the US or by Russia. Okay, so I think missiles in the range of 500 to 5,000 kilometers were taken out of the US arsenal. Okay, now what has China done? All the things we are talking about, they are either short range, 200, 300 kilometers, or you are looking at the maximum 3,000, 4,000 kilometers range, right? They all come in this INF treaty limits. Now, what the US could do, right? There are 2 things that the US is talking about. They have a concept called air-sea battle. Right? What does that mean? It means that they want to dominate. The US has never fought a war in which it has not dominated. So what they want to do is to dominate the space within the first island chain, within the second island chain. And in order to do that, they need a significant aircraft capability, right? They also need a significant enhancement of their navy. There's a lot of stuff that people are writing about. Okay? The point you want to make is all these options. So if they have to develop a new generation stealth fighter, for example, which can counter the Chinese air defenses, right? It's going to be.
They're also focusing on LRU, under surface vehicles.
Yeah. So the other,
amphibious
yeah. So let me come to that. So one part has to do with the development of new capabilities. To develop such a aircraft, for example, that can penetrate the protection that the PRC is now creating, right? It's got a very strong conventional, SAM-based or what I call missile. It's a problem much more complicated because it has to move resources around the world. From all over the world, it has to come. It has to group together. Before, for example, Iraq, it took 2 or 3 weeks for them to get their act together before they could move it. It's not very different. Geography is still there. In spite of all this IT, physical movement of, of platforms and weapons have to happen. It's not completely cyber or everything is completely gone. So the point you really want to make is it's going to be difficult for the US. Whereas if it has allies in this part of the world, then there's, just as China has an A2AD, the allies can also have their own A2AD, right? A lot of them are islands. We can do the same thing that China is doing, right? And that way we can actually deter China. So what I'm arguing is there's a whole range of strategic choices that is opening up. And the renunciation of the INF treaty means that the US is also going to respond, maybe not necessarily in the way of dominating the entire first and second island, which has always been their approach. Maybe that is not going to work so well with the Chinese case. That's how I would look at it.
Russia is trying for this A2AD capability.
I would argue Russia is a very formidable space power, okay? But it is not, shall we say, I would argue it's on the decline a little bit from the last few years. Russia and China will work together. I think that part, now they don't like to work with each other, they don't like each other, but because they have a common enemy in the US, I tend to believe that alliance is going to be stronger. I think the next 10 years we'll see a closer relationship. It's difficult to predict beyond that. Politics is evolving, changing, geographies are changing. So I would argue that, yeah, the Russia and China nexus, if you look at this region, there are a few countries, Pakistan is one, I think Cambodia may be another country. So the Chinese, what I call, ability to have allies in this region is much less than the US. And of course, countries like India, we will have to be neutral in a sense, but definitely with the US tilt. But we have to do our own thing. We cannot depend too much on the US because tomorrow Pakistan may become important. They will completely ditch us, like it has happened in the past. So we should be smart. We should ally ourselves with the US if required on many things. Definitely China is a greater enemy for us. US is definitely a friend. I mean, those long-term things are not wrong. But we have a number of choices to make, and it's kind of difficult to navigate these choices. I tend to believe our interests are more with the Western alliance, although not totally. Definitely we should be seriously worried not only about the military threat of China, there's a significant economic, they can disrupt our economy quite easily. So we have to look at it in a, I talked about applications, even to do the kind of stuff that we did, right? We were scratching the surface. I mean, even in the military side, you can look at 100 think tanks in India doing some of this work, right? We need trained people, not only political analysts, we have a lot of them, but we also need this combination of technical, political, economic knowledge people, right? We need these integrators also, and a lot of work has to be done. Satellite imagery is very powerful if you know what to use it for, right? But other sources of information are also equally powerful. We need to put them together. Not only focus on the space part, which is easy to do, but all the ancillary. See, this assessment requires also a lot of ancillary information which is available in the public domain. It has to be put together for us to make sense of it. So it requires a kind of, I don't know, we use standard. We need an application focus for a lot of this. We need to invest a lot of money in creating these capabilities, not only in government, where I feel it doesn't really flower. We need to go out and create it. Industry, think in improving a lot of this and a significant increase in scale. Right? We need to invest significantly more money. If you want my personal opinion, the manned space program is a waste of our resources over China. It's not that we don't have the capability. It's just that we don't have the number of satellites, right? And the number of things that we need to do. So if we put and create our own constellation based on our own requirements, it's a question of scaling up and being able to get to that stage. So we need about, I would argue, 60 to 80 operational military satellites at a given point in time. We need to create that constellation. Okay, I've identified all the areas. I have a detailed book. I'll give you the reference. You can go and access that book. Okay, it tells you all the things that we need, and so you can actually get a good idea of what needs to be done. See, people like us in the outside domain can only project, right? We can't do anything. So this is one part. So what was the first question that you had? The launcher that put it in orbit. We need to look at the launch site, where the launch site is in China, right? And then you can. So then you can say this is a SAR satellite or this is a optical satellite. This is an LNC. Worry, that's all.
Yeah. One other point is fleet operation.
Yeah.
The aircraft carriers have not carried out fleet operation in Pacific or in Indian Ocean. They haven't come out in full-scale fleet operation. Otherwise, you can't use an aircraft. Able to tell them.
See, I have to confess, I do not know enough about naval operations and fleet operations. I can only look at the architecture and say something about it.
Thank you.
Thank you, Professor Chandrashekar sir, for your insightful and dedicated A2D2 strategy PPT, and thank you for student fraternity for their insightful questions. Now we'll begin with the second session. So the countries are competing at the S&T, the science and technology domain, to get a hand on the technological efficiency. So this has opened a field for a new conflict and friction between the countries. China has adopted a much effort and a long extended procedure to get a hold on the S&T technology. Two of those are the chip and the artificial intelligence. Recently, US has barred the Intel and AMD to export their chip to China, which is a dual-use technology. So this shows that Beijing have done a tremendous effort to achieve a epitome, especially in the use of chips, and the chips are the integral part of the AI technology as they are used to process the data. Now this epitome that they have achieved in S&Ts can be linked or encapsulated by the Made in China 2025 vision. The policy laid down the foundation to achieve expertise in different sectors, most prominently information technology, robotics. So these include AI, Internet of Things, IoT, and machine learning. This policy is closely linked with Digital Silk Road, that is DSR initiative. Some reports also indicate that 1/3 of the 138 BRI countries are actually assigned to the DSR policies. In this changing dynamics of S&T, India finds itself in a conflicted conundrum as Beijing bids to become a global power in S&T and innovation. Delhi will face multiple threats in that domain. India needs to keep an eye on its adversaries regarding to China's development and achievement. To know more about this and this aspect, I would like to request Professor V.S. Ramamurthy sir to enlighten us with his insight and wisdom. Professor V.S. Ramamurthy sir is a well-known Indian nuclear scientist with a broad range of contribution from basic research to science and administration. Professor Ramamurthy sir started his career as Bhabha Atom Research Center, Mumbai in the year 1963. He is an elected fellow in 3 science academics, the Engineering Academy and the India and the World Academy of Sciences. As again in the first session we had an insightful question from our student fraternity We will think and we will expect the same from this session too. The question will be begin after the Ramamurthy sir ended with the presentation. So without extending further, sir, the floor is yours. Sorry.
Yeah, I will do that. Thank you very much. Now, we had a fascinating presentation by Dr. Chandrashekar. I have been trying to find out what he does because I see him doing something. I was not very sure whether I know what he was doing, but today gave me an opportunity to understand what he was doing. One comment which he made: you may build every capability, but if there is no fellow at the end, then nothing will happen. Human resource, right? And I have been looking at human resource, what they are doing, how are they doing it. They must have got something to make this possible. Whatever he said to make that possible, there must be a man behind them. From where they got that people. So this is something which I have been looking at it, and I must say that I am still looking at it in the sense that I am not ready to give a presentation like what Chandrashekar did. I am not yet ready to write a document like this. This is what has happened. But there are certain signals which I see, which all of us have been seeing, and we are trying to find out why are we not doing what they are doing, for two reasons. Number one, our population is almost the same, 1.3 billion. They have a lot more land, of course, but if they have got 1.3 billion people, we also got 1.3 billion people. Why are we not having those people who are delivering there with the available technologies, and why are we lagging behind? So I'm going to, whatever I have seen, I'm going to share with you, and hopefully one of these days, maybe 7-8 years down the line, some youngster will write a book on that. But we are not ready to write that book. Take for example, last 20 years and years before, both India and China became sort of independent nations, if you want to call it, in today's parlance, almost at the same time, 1948. And when I was young, China was known as a country which makes poor substitutes of something which happens elsewhere. In fact, one which I keep saying, which I have said this in this platform, the C3S platform, before, we used to have a camelin pen when I was in the school. Writes well. We had no complaints, and all of us will be proudly having a camelin pen in the pocket. Some fellows will come with a Parker. Right? I can't afford it. I look at it with sadness. But there were also fellows who were having a Parker in the packet, but they didn't pay like the other fellows because those Parkers are made in China. And we asked what happened and why they don't function as the Parker from UK. Turns out they were the Parker were invited to come to China to start a company to make Parker pens. They were selling it cheap, and one day they said, okay, now enough, now you can go back home, and send the original Parker, and started making duplicate Parkers. And obviously the products were not as good, and so we had a camelin, and we were happy to have camelin, and some fellows had Parkers, or they are happy to have their Parkers because they had the money, and a large number of them have duplicate Parkers, which was not. Today what is happening? Suddenly we find they is competing with the United States in terms of their GDP. It was almost sudden because from 1947, 1948 to year 2000, I always say both India and China were following the developing part trajectory in terms of everything, in terms of GDP. They were making so many changes. Some were negative, some were positive. We had our own achievements, we had our own failures. But both of us were saying we are together. We have the same characteristics, same population, nothing different. up to year 2000. That is the end of last century. I'll show you that picture how it was changing. But suddenly 2000 onwards, there is a big jump. They changed that trajectory. They moved away from the developing country trajectory to developed country trajectory, almost competing with them. Right? In which sectors? GDP. I don't understand GDP. Money. Finance minister talks about it. I don't understand it. But I do understand. Till 2000, they were saying, oh, China steals IP, China steals your students, China steals your material, everything. And 2000 onwards, they are having students. They are not stealing anything because their number of patents, they are the top number of patent filers today. They were saying 10 years before, China steals IP. Nobody talks, nobody says China steals IP because they are the major generators of IP today. Number of publications, they are almost the same as United States. GDP, 80% of the GDP in United States. That trajectory, whether it is in GDP, whether it is in publication, whether it is patent, is completely different today as compared to just 20 years before. This is something which caught my eye. This is something which I start worrying about. What happened? We had the same number of people. We had the same number of, almost the same training for the last so many decades. Suddenly they went from one trajectory to another trajectory. What is it? And that is the one which also contributed to what Chandrashekar was talking about. If there had not been locally trained students in China, they wouldn't have been delivering what they are delivering today. It's not the satellites which delivers, it is the man on the back end who delivers everything. And that where we seem to have failed, and they seem to have done something which is showing results in 20 years. Now, they went through a problem during the Mao Cultural Revolution. Scientists were sent to, so literally their science was killed. They came to zero. After mid-70s only, they started taking a different trajectory. Up to 2000, it was still the old trajectory in spite of the fact that there are new management. 2000 onwards, that is the only thing which I am going to talk about. And Chandrashekar has promised me that he will help me to collate all the things and ultimately come out with a book like this by somebody else 10 years down the line. Already too late, but it's still good to know what's happening. Can I have the first slide? Huh? 202209. Not that. Next. Go to the next. When I try to examine what is it which China did before 2000, after 1976, which seems to have made the difference. Identified, which Chandrashekar also identified. The first one was 1986, 10 years after the new management, the program 863. Program 863 made the following statements: strengthen R&D, research and development, not only in security technology, but also in emerging technologies. That was one major step. It was clearly made. If you want to strengthen your security, don't invest only on security, because with time, technology is going to make a contribution, and if you want to make technology contributions to security, you need to train technologies. So they said this is both research and development and in security technologies and also emerging technologies. The second one that they did was the so-called TORCH program. The TORCH program, which also came at almost at the same time as the program 860, nurture innovation and entrepreneurship, support entrepreneurship. You may recall, this is what US did in the 60s. You get all the students from wherever they are. If you don't have students, get them from wherever they are. Train them in science and technology and encourage them to make money out of it, because they know what the money they make comes to them. That's what has happened. Whether you have Silicon Valley, whether it is Boston corridor, ultimately there are a large number of students, 10 to 20% of Indian students contributing to that. Chinese students are contributing. Students from all over the world, they are contributing. They were not only United States or anybody else. Good student is the first investment you make. That will strengthen your S&T, that will make money for you. These two programs were done. And as you may, I will point out somewhere, the programs TORCH started in 1990. They formally had an incubator, technology business incubator. Interesting to note that we also start exactly on the same year, exactly under the same term, because the United Nations date. Okay, but they have moved forward. Then you look at the trajectory again, as I will show you. In spite of the fact that the 86 programs were done, very little impact on economy, very little impact on new technologies. Nothing happened. 95, they realized, listen, we don't have people. They were trying to invite people from United States to come and do their 1986 program. The only thing they got, yes, a few papers were obtained, a few patents were brought, and many people were said these fellows have stolen the patents from United States, so they got a bad name. There was no impact on anything, including the GDP, which I will show you again. So they brought this 1995 project to 11, strengthen education and research in about 100 institutions of higher learning, not 10 scholarships you give. Sometimes I laugh when they say we give 10 scholarships in the name of a Prime Minister. It will make no difference. You need to go into villages, and wherever they are, you have to do it. Then they also said 1998, let's create more universities of world class. That means it's not Chinese standards, but they must be internationally competitive. These two programs were done. These are the 4 initiatives which I could identify related to science and technology and education, and which, in my opinion, gave the results. Now, why do I say that? I will show you now. Next one. First thing, when they did strengthen education, strengthen research, strengthen universities, where should it show up? The number of students. The plot of number of students, university degree holders in natural sciences between 2000 and 2012. By 1998 was the policy decision to strengthen universities 1996 was a strengthened R&D. And where does the result show? 2002, number of degree holders started increasing, still increasing. The figure is up to 2012, even up to 2022, it continues to rise. Where are we? Here at the bottom. Japan, United States, everywhere. It's the only country in the world where the number of students is increasing with time. Okay. Now you see growth of PhD degree holders. Okay, graduates is one. Is that adequate? No. R&D people should be required. Now you have plot here, again 2012. It has started with about 7 minutes, I don't remember, and has gone beyond United States in 2012, and it is continuing to rise. Where is India? The flat line continues exactly the same. Our number of R&D students at PhD level has not increased in the last 20 years. It continues to be the same, whereas China is really increasing. Again, when did it start? 2002 onwards. Right? Next. Well, one parameter which I try to plot in a very bad way. I didn't know how to make the graph. Maybe somebody would teach me how to do. R&D personnel per million population in India and China from 1990. Our number is about 0.2, remains so at 0.2. Last 15 years, that number has not changed at all. Whereas this is not, it's almost true about United States also, but it is still increasing. Ours is static, flat, but it is increasing there. But there in China, from about 0.4, it has gone to about 1.5. Right? Something like 3 times it has increased about 10 to 15. So clearly, the decision to strengthen R&D, decision to strengthen university system, decision to increase the number of students who are involved in R&D, going up. And when does it show? 5 years after you started the policy decision, because an average student spends 5 years in a university. So if you start today that I will do it, 5 years later only you will see the first graduate. That is exactly what we are seeing here. So there is no doubt this is happening because of those two decisions, those two crucial decisions. It didn't happen after the decision 1986 that you will strengthen R&D. Just to say strengthen R&D doesn't lead to higher number of researchers and higher number of, you have to strengthen the education institute. Okay, what's the impact of all this? Next one. R&D spending also increasing. You see here, around 2002. Beyond that, they have already they have gone beyond European Union. They are competing very strongly with the United States. Right? Now, if you spend more time, more money into R&D, where does it show up? Like this is GDP. See the GDP up to year 1995. India and China are the same. That is what I call the developing economy line profile. It's the same. 1995 started increasing, but not big way. So effectively, the 1988 and initiatives have marginal increase, not a big increase. When did the slope change? Mid-2000. That means when the number of students and number of PhD holders, number of researchers started increasing, R&D funding started increasing, and it is in GDP, we are already competing. China is already competing with the United States, moving along. So clearly, in my opinion, the decision to invest in students, decision to invest in universities, and decision to invest in the research is showing dividends in terms of the economy. and in terms of GDP. Now, people ask me, how do you know it is because of that? There is, I didn't show you a direct connection. I'm not able to show. How do I prove to you that it is the student's investment which is giving this? I'm not able to show. One of these days, I will find out how to do that. Okay? But it is definitely, whatever happened time-wise, it is same. It's a matching. 1995, you made a decision, and 5 years later, it's showing up results, and 10 years later, you're already competing with the United States. This is clearly showing. And today, nobody will say China steals our patents or intellectual property, because they are number one in intellectual property protection of the generators today. So that argument is completely left behind, dropped behind. Yeah. Okay. Before I come to, I go to the next. Okay. This is GDP is too broad number. As I said, I cannot prove to you that GDP increase took place because of this, but I have no other reason to say why GDP increased now, not in 1990 or 1980. Right? I want to take up one sector, energy. Energy is the currency of the future. If you have energy, you have everything. In the whole world, in the world economy, if you don't have energy, you don't compete. Look at energy, coal. God has given, don't make coal. It's available. And India is number two in coal. So they are there, we make use of it. But we also know coal is a bad material for you, because it is going to create new problems, already creating problems. We must get rid of gold. Oil, China has no oil. They buy oil. Natural, same, natural gas. Hydroelectric, China has plenty, because large land area and plenty of natural sources of water. You are all aware of the Three Gorge Dam in the rotation frequency of the earth, and it was filled. So there are plenty of, effectively, traditional energy. Before 2000, China was number one in two, US was in two others. Right? We were all behind this. But the message was very clear, this won't work. Because this number one energy in coal is not going to keep them number one for a long time. So it was clear. So there was a policy decision that we will get rid of coal slowly. They are still the maximum burning of coal in China, but they have taken a policy decision coal and migrate to renewable energies. Now what are the renewable energies? Wind, solar. Okay. Now they were not in the race for wind or solar before 2000. There was no wind solar industry in this. Number one, wind. What does it involve? Wind involves, the wind is there, but you need motors, propellers and motors. The rare earth industry, United States to China. In a period of 10 years, in 10 years, they take the entire industry out of United States and establish in China. Can you do it? They do. But we know, Chandrashekar tells me how they did. Not all of them may be very royal or justifiable or anything, but they have done it. Take solar. Number one solar in 1990 was Germany. Germany was a major producer of solar panels. And suddenly you find Germany is gone. Do you see Germany? But China is. We also buy solar panel. The first solar panel which was used in Indian satellites was made in India. Today we buy it from China. What happened? Right? two things happened. Number one, they decided that we are going to make efforts to become number one in energy, because energy is important for us. And number two, they decided that you will get that technology by hook or crook. Again, if you look at article by Chandra, there is a quotation by the President of China that the magnets, rare earths, is what is oil for Middle East. We are going to become number one in rare earths. That was a statement made by the President, and they ensured they become number one in rare earths. All right? And this strategy is very simple. Human resource, IP, then you produce. Today, China has about 30% of rare earth resources in the world. They control 90% of the market of rare earth magnets. With 30% resources, they are controlling 90% of their magnets. They are controlling about 98% of high-end magnets. That means it's not only the rare earth resource, but also the technology. Right? And I refer to Chandrashekhar's article, how they did it, but they have done it. Now, we have about 15% of rare earth resources in the world. We always had. We had a rare earth department in existence in this country for the last 70 years. Indian rare earth has been in existence for 70 years. 15% of the resource in my backyard, technology among our institutions, and dedicated structures to manage this resource. And how much is our market share in rare earths of India? A big zero. A big zero. We don't control any of the rare earths magnet market. It's a failure. And we would like to know why there is a failure there and what should be done to regain my 15%. I don't want to control 95% of this, but to regain my 15%. And you may give you an example. There was a dispute between China and Japan because of that sea in between. Okay? And they couldn't settle everything. Something was going on. They quietly one day they said, sorry, we have some problem with our rare earth industry, so no rare earth magnets, high-end magnets will be supplied to Japan. And Japanese industry collapsed because there is nothing which doesn't have a magnet. Then they had to come to the negotiating table. Once they came to the negotiating table, rare earth magnet supply started. So effectively, they not only captured the number one position, they also started using the number one position to settle their political disputes. Nuclear. I am a nuclear physicist. Right? Our first reactors, power reactors came into existence in 1960s. Tarapur was already functional in the 1960s. Then we started making our own RAP and Rajasthan and other places. The Chinese reactor came into existence in 1991. The first Chinese power reactor, I'm not talking about the bomb, I'm talking about power reactors for electricity, came into existence in 1991. 64 to 1991, 30 years later. Today, they're already number 2 in nuclear energy, because in between 1991 and 2019, they have 50 more reactors and generate 50 gigawatt in 30 years. We have been making, designing, making, building reactors for the last 50 years, but we are nowhere near that. And brought them to number 2 position. But then you must also look at another one. United States has the largest number of nuclear reactors generated electricity today. They're the number one producer of electricity, that you see United States name. But where are they now? More than 80% of these reactors are 30 to 40 years old. They were built in the 60s and 70s, and the 2 or 3 accidents, the 3 Mile Island accident or the Chernobyl accident, they said, no, we are not going to put this, slowed down or closed some of the reactors. Net result is, last 30 years, only a few reactors were built in the United States. No new reactors were built. The damage is not in the electricity production. The damage is, today any student in his right mind will not opt for nuclear education, will he? In United States, will they go and say, I want an MTech in nuclear engineering today, when you don't build any reactors anywhere in the world? So clearly, nuclear education is going to be killed in the United States, whereas nuclear education is thriving in China. Okay. The Chernobyl reactor started the process. Fukushima created more problems. Not for Japan. Japan, on the day of the accident, they closed all the reactors. Within a month, they started reviewing the safety. Today they have said, in the next 5 years, 20% of new electricity for Japan will be produced from nuclear reactors. Germany, they closed everything. United States, they have nothing going on anyway. So clearly, nicely laid out, number one position in nuclear is going to be China in the next 4 or 5 years. What happens? Wind is number one China, solar is number one China, nuclear is number one China. We have offered the number one position on a golden plate to China. And energy is the currency of the future. Whoever has energy in surplus is going to be the market leader in industry in the coming years. Right? And not because uranium was not available, but because manpower was not available for making use of the uranium. And that's exactly what happened. Right? So this is a case where it is not making a bomb, it is not making a satellite, it is not making for anything, but it is simple day-to-day things. It's going to make a difference to you. Go back to the previous slide. What are the concerns for us, for India? When we are looking at China, not because we are writing a paper on China, but we want to know what are the lessons for us so that we don't lose out. We seem to be losing out. Number one, we are the same number of population. I told 1.3 billion population in China and 1.3 billion population in India. Approximately the same number of students. But then, we don't have that many students. Both at the undergraduate and the postgraduate and the research level. China and India have the largest educational system in the world. Up to SSC, they are almost the same. The fraction of students who complete schooling is not very different between India and China, but the number of students in the graduate education, postgraduate education and research, India is lagging behind. And one figure which I showed you, for every Indian R&D professional in India, there are 4 Chinese R&D professionals. As a result of those 3 or 4 initiatives directly. They have huge institutions. They have invested in universities because that was the 211 program. So consequently, a university like Beijing or Tsinghua has 50,000 students. And among the 50,000 students, almost 1/4 is an R&D, PhD level. Take our IIT system. IIT system is good. Everybody understands IIT system quality is internationally accepted. The number of IIT students have hardly increased. Only in the recent years we have started creating more and more IITs. We had a discussion earlier. Is it a good idea to increase the number of IITs or increase the number of students in each IIT? Right? If you build an IIT, for example, in Karnataka there are 4 or 5 IITs, new IITs, and the first few years the director is only a civil engineer. He has no time to teach science or technology. He is building buildings, including the wall. That is not the training. We need to increase the number of students. That was the starting assumption. So effectively, existing institutions who don't have 50,000, they can have 5,000 for every IIT. But when this proposal was put, they said, no, we have no hostels. So hostel decides the number of students we train, right? And suppose the hostel is not there, they will find a place and stay somewhere. Your classrooms are more important than the hostels. They cannot decide the number of students in IIT. That is what we are having. So net result, what is the net result? Every year, 2 lakhs students aspire to become IIT entrants. 2 lakhs. A big number. Out of which something like 1 lakh is declared fit for IIT entrance. Half of it, approximately. Out of this 1 lakh who are fit for IIT, as declared by the government, how many actually enter the IIT? 10,000. Effectively, we are making use of 10% of the people who have been declared suitable. Makes no sense. Every IIT boy should become should be in an IIT-like institution. More important, which is more important, today's system, the way in which go, because 1 in 10,000 in 200,000 is getting admission, that fellow, he doesn't believe on the plus 2 education. He goes to Baiju. Don't laugh. Baiju is the biggest damage for our education system, right? But we are not talking about it at all. We say, oh, fantastic, what is it? I don't know. New company has come up, unicorn has come up. That unicorn is killing you. We are not recognizing that. We had already seen it earlier. IIT entrance, you don't go to your school, you go to Rajasthan, Kota. Right? Now, another damage also, the fellow enters IIT, then he starts preparing for GRE. He doesn't learn what he is supposed to be learning in IIT. He says, I must just pass. But if I get good marks in GRE, I will get in one of the United States universities. So effectively, a good system, which is delivering even today, we are not using it at all. We have given it to somebody else. This is a problem which we have to solve. More important, skilled workers. Everybody cannot be an engineer. You also need an assistant to help him. I remember in BRC, we were building the plutonium plant. Plutonium plant is once it's commissioned, you cannot open it. And plutonium gas has only pipes where the liquid goes, plutonium liquid flows around. So we need large number of welders who are 100% efficient. You cannot have a mistake because once the system is closed, you cannot open it. So one stupid welder can finish. One stupid welder can completely ruin the system. So what they used to do, there is a welding research institute built for the boiler plant. Good quality students. So they hire from there, train them further, and he works in the plutonium plant. Plutonium plant is functioning today, by the way, right? But the point is, that guy after 3 years in the plutonium plant will be picked up by an oil industry from the Middle East for about 10 times the salary. So every 3 years they will be training more and more welders. Is that the strategy? Right? So what we need to do, we need something like an estimated, government estimate, we need about 13 million skilled workers annually in various sectors, whether it is welding, whether it is anything else, we need about 13 million. How many we train? 3 million. How will your industry thrive? They have to live with fellows who are not trained at all and use them. Is it possible? Or keep training everything? The industry trains the student where the educational institution don't. Then what makes sense? India clearly needs to scale up postgraduate education, research, and vocational education. All the three have to be boosted up. There is no question of that. Now, I also mentioned, okay, he has learned technology. Does he know how to make money? Incubators. Right? And I said, the incubator program in China and India started on the same year with UNDP funding. More important, after 10 years, after 5 years, we closed the program, successfully completed. After 10 years, they had 100 incubators. India started with the first. We successfully completed. Why didn't we start more? I was the secretary, so you may ask me that question. Answer you independently over tea. He knows. Okay. But today, they have something like 200,000 incubators. 200,000 incubators. We are about few hundred. We are putting right investments, but too slow. Clearly, India needs to scale up support for innovation and techno entrepreneurship. We are already seeing that, right? But most of them are self-made. Our system cannot take credit for that. But that's the way to go. That's the way US built, and that's the way China built, and that's the way we have to go, but we are behind. Then of course, India needs to encourage participation in industries. Industry is not always there to only to cheat you. They also contribute to it, right? He was saying Musk, right? Elon Musk. Where is our Musk? You will have to find out that. And philanthropic organizations, they fund. But then if I get money from, if he gets money from a philanthropic organization, he must be ready to go to jail also. Right? Otherwise it's not possible. And all non-government agencies are not cheats. They also contribute to national development in their own way. So there is a lot of thinking which is required to encourage these sectors also to in education, skill development and business incubation. We have not yet done. I am not worried about that. Someday we will have to start. What I am worried about is we don't even discuss it. We don't even recognize this is important. The new educational policy does talk about some of these things, right? But it is a 1,000 words document in which somewhere it is there. You will have to find out where it is, and then you have to implement it. It's not going to be easy. I always say India must learn to behave like a country of 1.4 billion people. We still behave like a colony of UK. UK doesn't believe it. We believe it very strongly. Right? So my conjecture in this, we have no alternative but to strengthen and invest in education and research. We have not yet learned that message.
A lot of students are still hungry. Food is getting cold, but we will not stop with the questions. We have a separate Q&A session with the permission of the
Professor NIAS. Dr. N. Ramani worked at the ISRO Satellite Center in the areas of software development for spacecraft mission operations and in the establishment and management of the Central Computing Facility. Led the activities relating to the design, development, testing, and implementation of software for real-time health monitoring and control of satellites. Pioneered the transition from mainframe world of FOTN and assembler codes to distributed computing based on off-the-shelf systems with the best of the breed engineering application software packages. Worked on computer-related issues that have overall impact on the organization, such as information security, software reliability, manpower attrition, open source and HPC. With Professor N. Narasimha, carried out the Indian Airline AVRO HS 748 fleet performance simulation for the airworthiness assessment for the National Committee headed by Professor S. Dhawan. Worked on several government committees that enable the computerization plans of ADA, CBDT, EPFO, and MES and SBI. He was awarded a Distinguished Aero Alumnus of the Department of Aerospace Engineering of the Indian Institute of Science and Astronautical Society of India Award in 1999. He was recently completed and validated a 3D missile trajectory program which can provide the path of the missile from any launch location to any target.
To all of you. Chandra in his presentation first mentioned about two software packages that we have developed at NIAS. One was about, given the set of the parameters of the missile, such as how many number of stages are there, in each stage what are the, what is the propellant that is carried, specified in terms of the specific impulse, and such as those, converting to its performance, what kind of range it can reach, if the target is within the maximum range that it can do in a direction, can it reach the target? Can it reach by a shallow trajectory, which is hugging the surface of the earth, or a lofted trajectory? They have both their own advantages and disadvantages. So that is the purpose of the first software that we developed. That has been used extensively by Professor Chandra as well as some of our colleagues. Whereas the second software, which has a much versatile application area, is the one what we call as the in the domain of space situational awareness. That is, in terms of ISR, it is in intelligence, surveillance, and reconnaissance. What kind of capability that your enemy possesses? To be able to determine that, we have developed a software. Let me give a narrative about how does it start, then how do we interpret the results, what comes out of it. Now it has a very excellent GUI, which makes the life of the user very simple. We called it as VNIVDVC for the lack of a better word. The reason being, otherwise I should have used Tamil or Hindi. So, but then we preferred to use some language which we didn't know. But it has a good meaning. VNIVDVC means that came, saw, conquered. Well, it has a connotation which fits into this thing. As I clicked on the icon which was there, it opens up with a simple display which consists of two parts. On the right hand side is the three-dimensional view, on the left hand side is a two-dimensional view, and it has a screen something like this. So there are, like similar to any simple application like even Word, you can recall an existing configuration, you can edit it, save it, or totally construct a new configuration. So the moment you say simulation, it asks whether you are going to run a new simulation or you are going to use one of the existing simulation. Let us see what that, if I identify by a name, for example, this is the local area, this is a set of 26 satellites, which are identified from the Yogan constellation. Yeah. There are, this particular configuration has 26 satellites. All are from the Yogan name, because what we are trying to do is trying to run by this simulation. We are trying to assess what kind of capability the China possesses. That was presented in detail by Chandra. When we say what kind, they have large number of satellites, but we have taken a particular subset because based on the analysis, one can either introduce more satellite into this, which means joining more resources from what is available in the kitty, or you can drop out some of them and see whether there is a degradation in the terms of coverage. Now we have recalled this, the process of validation. I will come to the more nonsenses of this software a little later, but let's first see the way in which we can start the run and complete a successful simulation of this. Now we have recalled this. Now it said that there are 26 satellites to begin with. If you want to look at all the satellites that have gone into this, this is the list of all the satellites, and you see that the sensor that it carries is the L-int, right? L-int has two parameters. These two parameters can be defined with respect to a reference altitude and a reference slant range, or if you don't have that information, you can simply substitute 0, 0, which means it will compute horizon to horizon coverage. So, which is the computed taking into account that the value input is 0, 0, right. Now, if you want to add a satellite, right, we can add from here, but instead of going into the books and finding out, now supposing I try to add one of them which is already there, it should certainly, first I have to edit this. I wish to edit this particular configuration. They all will run like typically in same lines as any other software, like Word or PowerPoint, whichever it is. So, supposing I want to add a satellite called, first of all, satellites are identified by the NORAD number. NORAD number is the unique identifier. There are other methods like international designation, but NORAD number is universally used. So, this is a database which is run by the NORAD, which gives for all the satellites, there are what are called the two-line elements, and there are also the three-line elements. Three-line elements are basically the two-line element plus the name of the satellite. Now, let's first begin with a particular number 3901. If I enter this, it should say there is an error because it's already there in the fleet that you have chosen, right? So, it doesn't let you do that, but let me remove this for the convenience of 3901. If I enter this, it should be able to accept now, because I knew I want to maintain that. Now when I click validate, because all human input errors are, human input are prone to errors. So NORAD number being 5-digit number, any 5-digit number looks like any other 5-digit number. So 39011 is what we saw, it was there already. So, and it says now, it goes to the database of this three-line element, fetches that satellite name and displays it, so that in the expanded form, you know whether this is a satellite you meant. Now, what you see is mostly trivial, general knowledge approach to designing a software, right? First of all, the input must be free from errors. We are making sure that if this information is flashed, the user pays attention to this and says, yes, this is what the satellite I want. So after that, he defines whether it is an optical satellite or SAR center or L-int. So now if you choose L-int, the reference altitude or reference slant range, now that means this is acceptable. It has accepted this. However, this satellite visual characteristics have not been defined. This would have gone to the very end possibly, right? So now we have to, yes, I define this as this, and then save setting. Save. Now that means I went back to the same old configuration, only after demonstrating how easy it is to input a new satellite into this. Okay. Now, then after defining the fleet of satellites, we have a method of defining the targets. The targets are there are 3 types of target. In fact, 4 of them are there. Point target, which is a fixed point on the surface of the earth, which is latitude, longitude. And that I have chosen now for the purpose of study, which we have done now, Okinawa, Guam, and Taipei. Taipei is the other thing, 3 things. And there are latitude, longitude is defined. And point moving target is possible. That is, it starts with a position, latitude, longitude, and you can define the waypoints. You can define it by about 6 waypoints, so that the target is moving. It could be an aircraft carrier or whatever that is. And generally, aircraft carrier is defined by an area, because it's not a single element which moves. It is an entire configuration which moves. So it is normally defined by an area. But whatever is the definition which is given with particular movement in a direction, the area target is, it can have 6 vertices to a maximum. It can be up to 1000 nautical mile by 1000 nautical mile area to a resolution of 1 nautical by 1 nautical mile. Now, having done all this, then we have defined 3 point targets, and we have defined one area target. Now we are ready for starting the simulation, right? If we start the simulation, now it fetches the database. At this point, I should mention, it can function both online, which means it will access the NORAD database in real time and fetches that information from the NORAD database. Security organizations don't want this to be known to the owner of the database. So it's possible that they can download it offline and present it as a file, so it will read from a local file. In order to be able to read from online, obviously you need the internet. Many security organizations will not like that to happen. So this can function without any interruption to the simulation that it carries out, without referring to the online data, which means it doesn't require an internet connectivity. Now, because there are too many of these satellites, obviously this color configuration also is a bit funny. So what we can do is, we can shut down many of them for display purpose. The simulation will be carried out for the entire set of 26 satellites which are given. In order to avoid the cluttering, we can choose. There is a sluggishness in the way in which it is progressing. What it does is, now on the left hand side I opened up another panel in which we see the parameters of each satellite, and one of the parameter that I am changing now is the display characteristics. I say that it need not be displayed. So, which essentially means the circular coverage will not be seen, but whereas it is taken into consideration for all computations. Right? I am sorry, the response is a bit slow. So, pardon me for a little bit of time, so that if it becomes, but I'm trying to switch off one by one. When we do that, the display quality will certainly become better. If you have a better computer, better processor, display, etc., this can certainly improve. Now, now in the meanwhile, you can look at the set of parameters which are there. It gives the NORAD ID and the present latitude, longitude of the satellite, and a whole host of them, including what are the characteristics of the orbit in which it is, etc. Now, assuming that we have done all the display characteristics which I want to choose, we have chosen. What we want to shut down, we have done. Assuming that, let's look at the other parameters that we can monitor in this. Let me do it once. I will switch off one more. Okay. Right. I'm just shutting down this particular display. Right. Now we see that these 2-dimensional, 3-dimensional displays are there. it is possible that you can mix and match them, in the sense you can ask for entirely a two-dimensional view of this, or entirely a three-dimensional view of this, or you can even look at without the display parameter, other things. You can see the full display apart of it. Still, it's very cluttered. We need to do only one thing. For that, we have to switch off more satellites, and that can be done anytime by opening up more. I think unless we do some more. Yeah, now because some satellites have been shut down. Yeah, now one more display update, it will bring it to the right order. Now, meanwhile, I will mention about there is another panel which is hidden that opens up with the what is called the simulation rate. Simulation rate, now at this point in time, the integrations are carried out at once a minute, which is optimum as we have figured out. But it is also possible to, you can run this 10 times faster, 20 times faster, etc. Faster depends on, obviously, already it was struggling to run this at the normal rate. So we obviously cannot run it faster than this. But at least it will do one thing. The resource squeeze takes place more from the display. So what it will try and do is, it will display, supposing you choose 30, once in 30 minutes only the display will be updated, so that the resources saved for that purpose will be used for the computation purpose. Then we have the pause and we have the stop button, right? So still we can try and do it at, say, I have set it as infinity, so that I want to go to the next stage of, now you have two other sections of the display, satellite, target and observer, which is essentially, if you go to the satellite, I should be able to see all the satellites, so that I can choose any particular satellite with which the entire display will be centered. See, because the panning takes place all the time, so the panning is centered around a chosen satellite. Or it is possible that you can choose this with respect to a particular target, or you can choose to center it with respect to a this, it says it's not done yet. That is the observer, we didn't also input. So here are three other buttons. They provide you an opportunity to place your target wherever you want at the run time. The other targets that we saw was, it is to be predefined before you begin the run. Now here is an opportunity, depending upon the progress of the run, it is possible that you can select this and position it in some place. For example, I can choose, place this in the current map. Should be able to do that. Let me, yeah. So this is with respect to, you can place a target in a particular place, it will be taken for consideration from then on. Right. Now, what else I need to say? Well, okay, we have now set it as infinity. So the simulation, when it comes to a close, what we saw so far was only a display. Display is only for being impressive for a person who looks at it, doesn't hold any, gives any strength to the analyst. So what we need is actually the information about what are the coverage patterns with respect to every satellite, with respect to every target, every satellite, how does it look at? What are the accumulated display percentages? All these are available when the run completes. At the end of it, we have a report which is generated, which presents this information. Now, yes, the simulation is reached because we made it faster. It is a one-day simulation which has completed in about 5 minutes. So I can close this. Yeah, I'm looking at the simulation that we did was with respect to, yes, this one, and there are two files which are generated now, which are, is this a run or 26? Sorry. Yes. This presents all the details that were presented by Chandra in terms of this is listed out in terms of sequence of events, which means the first event started at 4 minutes 8:4:22 to 12:03 to 12:03, which is for a period of 4 minutes, and it is the target is Type I, and the satellite that saw it is Yogan 31K, etc. What we collect, what was presented by Chandra is selected columns of this. If this is too clouded, we can remove certain columns, or if some information is missing, we can always add. Because basically during the simulation, every aspect of every satellite looking at every target is collected. So it is a question of what we want from this output. During this time, there was a question about whether such and such characteristic of a target, can it be recognized by this? While certainly, the corresponding sensor has to be capable, but we have some feedback from one of the major users. In fact, Navy Bombay is using this software, tech. So the same response which comes from them is both positive and negative for the software. One is they have taken this whatever gap it shows seriously, and they are of the opinion that whenever you want to switch off or whenever you want to switch on, we can't do that. Our operational considerations are different, which means if you say that there is a possibility that Chinese satellite will be looking at you, they are taking it seriously, right? So that is why they, on the face of it, they don't agree to that. The other one is that at the same time, if they say that you cannot control them when they want to operate, the software itself has no value, right? Because you are saying at such and such time it's going to be seen. They don't want to take this seriously, but you can look at it either way you want. The fact that whether this particular sensor can be particular characteristic of the sensor can look at particular characteristic of the target is a point that you can debate, and correspondingly, as long for anything that any target which has a certain characteristic, correspondingly there has got to be a sensor, right, sooner or later, which will be capable of picking it up, and that is what has to go into the onboard characteristic of the satellite. Now I will stop at this point, and I am ready to answer any questions if they are, and if somebody wants to take it up on a separate independent session, I am available. So I am willing to spend some time with them. Thank you very much. That is not our concern. No, but we have put in so much of satellites from China. But if you give us any other set of satellites, the space asset as we call, the same thing can be run. No, this is available. Most probably, you see, what is the hardest part, if you ask me? I can go through this. This software anyone can develop. It's not a big deal. There are lots of commercially available software, except that fortunately they are so prohibitively expensive, nobody can even touch with a barge pole, correct? So they cost millions of dollars. Obviously, this doesn't compare favorably technically with them. This is some kind of it's a beginner's paradise. So now, whereas if such a thing has to be done, anybody in the university can also do that. There are some tricky portions in this, which possibly, if somebody puts a patient thinking, can certainly do it. I am willing to hand hold with them and tell them how this is done. Yeah. Yes, sir, please.
Know that it's a alienate or any type, what type of sensor they have. So does the, because En-road I think it have the details of the satellite. So the software retrieved it from there, or it has to be fed by the user itself?
See, NORAD ensures that for all the satellites which are there, except their own spy satellites, they make available the orbital information about all the satellites. Obviously, about Chinese, they have all the information published. Now, what do they guarantee? They guarantee a certain accuracy. At the epoch is the reference time at which they publish the orbital element. It is better than 1 kilometer. And it decays at the rate of 3 kilometers a day, depending upon the orbit of the type of the orbit. For example, something like space station decays once in 4 hours. It exceeds the error limit which is acceptable. So what they do is, using the tracking data of those 4 hours, they will update that information about the orbit. Right? Now let me complete. What it means is that NORAD updates it as and when necessary. Necessary for what? They guaranteed a certain accuracy. Always they comply with that statement. Right? They will, as and when it is likely to go out of the accuracy promised by them, they make it available. Then what do we do? As and when available, we take it. So that means we assume that it was necessary, so NORAD did it. So because NORAD did it, we take it. So we are in the process of online contact with them all the time. In the sense, not with them means what? It's a machine. So there is a database, you make a query. So that query part is generally, this is published information available for single satellites. To convert it to 30 satellites, that requires quite a different way of looking at the same software which is there for a single satellite to multiple satellites, and interleaving them with the time step from movement as well as satellite changes, target changes. That becomes a bit clumsy.
Sir, I just add one.
Please.
Sir, Chandrashekar sir was mentioning that the same software can be used to predict. Like this is the thing that is run, like that happened. But the prediction part, if that can be shown.
It can do prediction. For example, if you have, if you want to predict for say next 3 days, right? Obviously, you are making a prediction with respect to the even orbital information. Then you are governed by how much accurate results can be got from a theoretical model that you have computed using. See, if it is about the past, it must have been improved with the tracking data. If it is future, it is only a prediction right through. It decays at the rate of, as I said, per day, it will be something like 3 kilometers. If you are willing to accept that kind of inaccuracy, that's fine. So nothing more can be done by anybody for that matter, because you need an orbital prediction theoretical model, right? This is one of the best theoretical models that is available, right? When we sit down to
off by 10 minutes. It's a pretty orbital.
Yeah, you can see it another way. The way in which the results were presented by Chandra, it reached that 88% within about few hours. It remained so right through full day. So whatever I make in the past, say let us say what I did for last week, is going to remain the same for next week also. That's another way of looking at it. Because if you make a prediction, be sure you are introducing theoretical errors. Because no model is perfect. Even NASA cannot produce them, they can only make it better. Yes, sir, please.
Always a fear that the GPS could be interfered with certain wave propagation from the ground. And there was also detected interference with the GPS satellites. with so much of information that you are able to derive mathematically or through your programs, would it not be possible to interfere with those satellites and see they don't look at the target?
Generally, if it's a communication satellite, you possibly can,
Jam it.
Jam it. But then they have other methods of escaping from the jam. It is counter.
Counter going on. Even now.
Neither I am good at answering that question, nor I can handle that in the program. So.
So the geography is considered as about your opponent doing a baseline. So my point is, Raman is very modern. I can tell you that whenever we want to look comes with it. Most of the time I know that so the methodology, so it is not super duper. I would argue that again. Accept that. You can argue so many ways. What about fact? Largely.
What is
Yeah, so my point is it's not that know a lot about
particular software we're talking about. How does this augment, or in what way is ISRO's recent center known as IS40M? How is that connected to this function, and how does that function or that center take this particular operation forward?
I mean, this particular tool, how is it? They do it, as I know, in the particular case where a particular Navy unit is using it, is when they want to do what do you call as the demonstration? It's not called a demonstration. They want to do a rehearsal. They want to do a rehearsal, right? Wargaming. Yeah, that's more precise. So then that is the time which they would, if there is a possibility of a satellite, Chinese satellite in that contingent is likely to pass over, you stop doing that gaming. So that's what the operators objected to that, saying we can't keep shutting off on now and then. Okay, so which means if they don't shut off, that means the satellite can pick up. That is their fear. That's why they refuse to, viewed from one point of view, they are aware of the fact that if they put it on, right, as I said, LNT cannot, it is something like saying, ship is the safest on land. So aircraft carrier will certainly safest when it doesn't emit. But that's not the role. It has to do something. No, hypersonic. Yeah.
You're actually doing it from on the other side of the. Now you could have something in low Earth orbit, like 200, 300 kilometers, and through minimum maneuvering, you can actually come and re-enter it from any part of the world. So my argument about the hypersonic, here we are looking at an ISR problem. It is only to know where a target is and how do we go. If we are not looking at defending against any, all the other things for offense or defense you have to do based upon this information. So this only provides information. Right? It does not address the larger issues of war.
Two things. The first one was regarding the satellite, doing work when the satellite is not above your head, so that you can avoid being detected. I am reminded of what India did 24 years back in Pokhran, right? We avoided all the American satellites when we were doing the work. So that was one thing.
I am sure an astrologer has helped them.
Sorry?
An astrologer has helped them. There did not exist any capability at that time to do this.
And there were much less number of satellites.
To the Pokhran fire.
Yeah.
That is, there existed no capability of this kind.
Yeah.
Certainly not.
Yeah, and now with the a gap of only 2 or 3 minutes between the visit of the satellites, you cannot do that anymore. That is.
That's what.
That's what.
First, I argue that the American the problem was in my more like an organization. Here also we are working on the possible organization. Or when you say political something else.
Yeah,
Sir, my feeling is if I stretch my neck out, I don't think the Americans did not know about it. They knew. For their own reasons, they didn't bother about it, ignored it, or did not share this with others.
Anyway,
there
that was
nothing that can happen without their knowledge.
Anyway, that was the story that came out at the time, and so I'm reminded of
did it
that.
and things like that.
The second point I wanted to make was regarding the NORAD data that you are getting. Now, don't you think that India should invest in SSA?
Absolutely.
In SSA kind of thing, so that situational awareness of space.
Professor Ramurthy had the answer. You should have woken up for this 100 years ago. So now if you come up and start this, I don't know when you will be ready.
Really have not made this investment, but after we produced our first report, ISRO has now gone up and set an office for space situational awareness. Huh? It is not called, but so they are doing it. My point is you need to make a lot of investments. There is also a new possibility. The Americans, and I'm sure the Chinese also, they have put satellites in orbit that can look at other satellites. Yeah, so I think that is also a possibility. And in a sense, it will be an easier possibility than this thing we have also presented to ISRO. I have a report which I presented. All of it is covered, but what they are doing, of course.
Sir, that is easier, as he said. The easiest method is to get into collaboration with NASA, which we are very good at.
No, but we know that ISRO is doing that kind of. We know that ISRO is keeping track of the objects in space because of their own launch. Should not get interfered.
No, where are they? Do they have an independent capability?
Yeah,
the answer is no. No.
But like what?
That I can challenge, because the only software that they have which can do this is an American software called the STK, right? That's what I said as $1 million. So whatever it is, they don't have the capability. They have a director for a center which is created, right? I don't think they have a wherewithal. They are always after what's called the high precision data. It's nothing but collaboration with them and getting it in the way they want. They can always find ways and means of achieving the end goal. But yeah.
No, but so that reminds me of the damage that was done to India's RISAT-1. It was due to a space debris that the JCPOA, the Joint Commission of
same thing as NORAD.
They detected about a month before that happened.
So there are two problems. Calibrate. See, RISAT, the Indian, so there are two RISATs, I always get confused between them. The Indian RISAT, the Indian built SAR, had this huge solar panel because SAR requires a lot of things. So I think one of the RISATs, which was Indian built, started shedding. You know, because of the size of the panel and because of the orbital issues and the solar panel, I don't know what the other things were, it started shedding a lot of debris. Okay. So one of the problems with RESAT, one of them at least, was the debris problem that it was creating. NASA was pointing out that that was the problem. Now this fact was not reported in India. Okay, it was only known to NASA, and I think a limited international kind of circle. I happened to read it somewhere because somebody sent it to me, so I kind of came to know about it. But this is one part of the story. So the debris that the RESAT created is actually self-generated debris in a sense. Okay. So I think that is the real picture, and ISRO does not officially acknowledge it yet. Okay.
You are right, sir. Every missile rocket launch of ISRO is to be preceded by what is called the conjunction analysis, right? That they get this information from somewhere from NASA only, right? They must have a collaboration, or if you you are willing to spend more money, conjunction analysis report will be produced by an independent company. Why you need to get the data, compute, and go wrong in that? You can get the report itself.
They are sending create the space situation awareness.
No, nothing but they are tracking satellites. You carry out the tracking instead of from ground, you do it from satellite. So you have much better coverage.
You can do differently. You get a large spectrum. Particularly, you want to look at understand what it is.
Accuracy of the orbit is based on the geometric segment that covers, which can be done as long as you are talking about the ground-based tracking. The ground stations must be distributed geographically. That may not be many times possible because it may not be in your soil. So space-based observations are much better.
1.5.
They go wherever the requirement launch or a particular, wherever there's a rocket launch, they are going back to the point. They have a major missile tracking. They definitely can record all the data, objects and all. They are actually. So they must have gone to Sri Lanka largely for replication. That is really interesting. That is
I just want to say one thing about the Taiwan analysis which Chandra did. What did they demonstrate? Chinese demonstrated they can do a precision bombing in and around Taiwan, right? But when do you bomb unless there is a target there, right? That's what this this particular analysis is likely to fill. Sir, I know Professor Ramurthy sir is getting a lot of ideas from this, but I don't.
So, due to time constraints, we'll be moving on.
Sorry.
Thank you all for the interesting questions. Thank you very much for a very interesting and engaging presentation.
Thank you. Namaskar. Thank you.
So, I request you to kindly take a seat on the dais.
No, not me.
I now request Professor S. Chandrashekar, Professor V.S. Ramurthy sir, and Dr. N. Ramani to take the seat on the dais, and we will start with the question and answer sessions.
Okay, it's always a first time. Okay, just a few points from me before we throw open the floor. I think we are very fortunate that we have these three scientists who come here and have given their perspectives of what it is, particularly Professor Chandrashekhar's briefing, his presentation, and what the present day capabilities are. You know, as a military man who's been in the Navy for 34 years, I understand the field requirements and complications thereof. He started off with the ISR requirements. No? Intelligence, surveillance, reconnaissance. In the Navy, in the other armed forces, we talk about C4ISR, command communications controls, and thereafter include the ISR. There are many I2SR, IS4R, all this gets added up, but it doesn't matter. The point is there is a basic requirement for you to have a surveillance capability. You know, come a long way from Pokhran, which was discussed here. And today, you saw the constellations that are there, there is no escape for you. Now, whether it's 1 mile area or whether it's 10 mile area, you are under surveillance. But only thing is, with the kind of predictions that can be made, you can perhaps be, using AI and other mechanisms and algorithms, maybe in a position to say, if these constellations are this particular configuration, maybe they are in a position to now launch an attack, or they are preparing to test out the complete C4ISR mechanism by these constellations which are there, which is, it is not a surprising fact that after 2-3 hours, 208 minutes, I think he showed in one of this, thereafter the probability is something like 88%, which is very high. So, what is it that we need to know? One is the point that's been made clear, not only now, even at the earlier time when Professor Chandrashekar come here has made it very clear that we are lagging behind. We're not invested enough in our satellites. We're not invested in the ecosystem that support the entire gamut of satellite surveillance. Professor Ramani brought out the need on the INTEG. INTEG is basically, for those of you who do not know, it's the Indian Naval Tactical Evaluation Group, so which has been there for 50 years. Now I've been there, I worked there, and those days itself, I'm talking about 40 years ago, where they were using computers to look at simulations. Today, the kind of input that Professor Ramani is giving is something that's integrated into that, to create a picture, from where you derive the probability. No, so this is mathematical. There is purely mathematical equations and a lot of computer dynamics go into this, algorithms go into it, and it's being refined continuously. A lot of money is invested. Dr. Ramani will know that in INTEG, we put in a lot of money just to refine the systems that are there. There are huge screens in phenomenal rooms where we can play out a complete war game, where these are injected, the kind of satellites that they are using. Of these satellite constellations that we spoke about, it's not just one type of satellites. We are looking at very specific capable satellites which require SIGINT, ELINT, SAR capable ones, which he clearly brought out to say they can only look one side. So, the optimization of the resources that you have put in the skies, the eye in the sky as we call it, is something that adds to his potential. So, the Taiwan scene that was painted so well by Professor Chandrashekar told you that, they carried out this exercise, but who are they firing at? It was to convey a political signaling. It's not just about a SLT capability or a capability to launch a missile. It's more about signaling that was there, which came out because of Nancy Pelosi's visit. So they said, we are now ready to carry out attacks in these 7 areas. That was to say that we will keep you out of these areas which are of importance to us. So they also fired into the exclusive economic zone of Japan, into other Philippines. You saw those, the figures which are shown there, 1, 2, 3, 4, 5, 6, 7, which are shown, showed you the kind of surveillance capability that they have. As I also said earlier in the remarks part, the fact that you are able to push the carrier force. The strength of America is the carrier battle group. The carrier battle group, which is fully commissioned, they have 11 nuclear powered carriers, and each of them propels something like 100,000 tons. And they carry 95 to 120 aircraft, all descriptions, AW aircraft, logistic support aircraft, fuelers, fighters, bombers, everything is there on that one floating city of the carrier. China is nowhere near this. Nowhere. Let me repeat, they are trying to reach there. They have 3 carriers. As has come out in many of our discussions, none of these carriers have not even crossed the Malacca Straits. Why? Because that kind of a capability that America possesses is yet to be realized by China. They are working towards it very hard. In fact, even just about 3-4 months ago that they started trying to integrate their AW aircraft, onboard AW aircraft. All these are Western copies. Of course, with Professor Ramurthy says, yes, they perhaps stopped things from 2000. I don't believe it. They continue to copy. They continue to have their people from PLA who are going to USA to get those secrets. And after the standoff which was there, they clearly said we are not allowing PLA people to come into our universities. No, because they were coming as academics from the PLA. So there's a big game that's going on. China will definitely match USA in terms of their surveillance capabilities, that there are no doubts whatsoever. Because the number of satellites that they are launching, the kind of systematic planning in keeping areas of importance under surveillance, whether it's the Indo-Pacific area or the Indian Ocean region, all this is extremely well integrated. There's one slide Professor Chandru showed, which had the DF-21 kind of an ASBM, which was in the center. And you saw the network of what all was going into the information feed system, which enabled you to fire a DF-21 or whatever, or an advanced version to the carrier fleet. It also came out in the discussions that, the carrier, since it moves 300 nautical miles every day, you can't pinpoint it. And also there are many countermeasures that both America and India have looked at. It's not that just because DF-21 is fired, a carrier is sunk. It will not happen like that. So don't be under the impression just because they have the capability to fly at 10 DF-21s, one carrier is sunk. It's not going to be like that. Why did they prove the concept of 2007 ASAT capability? Why? Because they know you have to gouge the eye of your adversary, you blind him. After that, where does he control it? The same thing that the America follows. So you think they don't have counters? So if already one DF-21 has been, you are at war. And the next stage, believe you me, will be shooting down of satellites. It will happen. So, it's not all black and white. There are many of these grey shades which we need to understand as researchers. So, no, don't just think that, he's got all the capability, he's got multiple things. The revisit time is so good, and therefore, you are under surveillance. How do you counter it? A simple example I'll tell you. A carrier. How do you recognize a carrier? You recognize the complete carrier group because there are protective forces around it. It's filling in a particular direction. With the SAR radars, you are able to make out the contour. The synthetic aperture radar or an ISAR is able to today define the contour of a carrier, which is how they can make out. So what are the counters? If you do not have a carrier battle group like the Americans, the counter is simple. The carrier does not operate in a carrier battle group. It merges with the sea lines of communication. It disguises itself. All these have been tried out. I'm not talking in air. We tried this out to reconfigure them, camouflage them, hide them from the view of the satellites, because the fact that you are 24/7 surveillance is something that is accepted and put into the picture of our planning. Not that you are insulated. You are better prepared because you know what the adversary is doing. So these are some of the factors that I want you to remember before you start asking the questions to them. Because it's not that China has conquered the space world and everything is hunky-dory. They have their own issues. Particularly the one which was related to what he brought out. It's not that the Americans perhaps did not know that we are working on Pokhran. But the information overload, the information system, it happened even in 9/11. They said there was enough information. But the analysis was so skewed, nobody was willing to say that, this is something that's likely to happen. There was enough intelligence. It's all been analyzed. So, so when we are looking at this, I'm very happy that today we are looking at this as part of our SNT vertical, and you could not have found better people than the 3 who are here on the stage to tell you, and particularly the model that Professor Raman tells you that today it can be done. All of you are IT savvy. So this can be done, integrated, given. So I'm happy that he shared it with Integ, and Integ has given them the feedback which are required, both positive and negative. So with this, I thought I'll make some observations as somebody who's been in the Navy for 34 years. And to try and get the whole correct perspective right in terms of what are the challenges that we are facing from the skies above, and how are we going to prepare. Obviously, the first and primary requirement is to invest in equal number of satellites. Without satellites, who are you looking at? How are you looking at them? What are your counters? So there are many questions there. So with this, I'm not going to sum up the whole thing, which is towards the end, but I thought I'll allow a little more time for the youngsters to ask your questions. So the house is open. We have another 25 minutes or so. So the first choice is for all the youngsters. Only when they exhaust their questions will we open it out to the other veterans who are here. Thank you.
Good afternoon, sir. Myself, Nitin Prabhu. I am from Department of Defense and Strategic Studies, University of Madras. Sir, my question is to Professor S. Chandrashekar, sir. Sir, my question is, is regarding space debris handling. When it comes, especially in China, why China is showing, behaving like an irresponsible attitude when it comes to handling the space debris? Because we had seen China recently, they have for the past 2-3 years, they have sent, they want to create their own space station, Tiangong 1. For that, they have sent Long March, but they didn't. They didn't properly concentrate on this handling their space debris. Recently, July, August month, at 21 ton of like their core stage of their the rocket booster. It actually uncontrollably re-entered into the atmosphere, and it fell on this our Indian Ocean region. So, what's your opinion on this, and how we can avoid these things? And my next question is, we are now the entire world community is like we are looking for improving, developing our satellites. Sending our satellites into space. At the same time, there are a lot of satellites that are their lifespan already got over, but still it's revolving in the orbit, and we didn't take much efforts to address this issue. What can be done in future? And also I read something about the Kessler's syndrome. If something like that, if it happened, it would pose a serious threat to entire the satellite arrangements of other countries too. How we can avoid these things?
A lot of questions. Okay, it's kind of difficult to answer all of them. Okay, so I'll try to give you a brief perspective. Okay, there's a lot of talk about China, right? And the main there were two incidents. I think one was the re-entry of a booster stage of the CZ-5 vehicle, and the other was the problem of the re-entry of the Tiangong 1, right, which came up and created a big scare. Now this is not new. Okay. So let me go back. This goes back in time to a long history of earlier problems that have been created by both the superpowers, which they choose to downplay now, and which some of them will also have even in the coming future. So one, of course, is to single out China as to say that one of the, and let's not forget, India too has created some debris about which you don't know because they don't talk about it. Okay. So debris is a kind of requirement that comes out of every person who is venturing into space. Because every time you deploy a satellite, something or the other is going to go out. So that's the reality. Okay. Now coming back to this debris issue, I don't know whether any of you know a little bit of space history. I think about maybe 1980s. Okay, I still remember very vividly. Okay, there was this Cosmos Skylab. I'll come back. There's another version of Skylab which I have to tell you. Cosmos 954 was a Soviet satellite. It was an ocean reconnaissance satellite doing exactly the kind of function that I was talking about. It had a nuclear reactor, active nuclear reactor. Okay. It got out, it lost, it had some problem and it went out of control. It crash landed over Canada and spread debris over a 2,000 kilometer area. Radioactive debris. Okay, now this is well documented. I happened to represent India at the UN at that time. It came up for negotiations both in the Outer Space Committee, all kinds of negotiations happened. But Canada and the Soviet Union finally settled it out of court, which is what they should have done in the first place. So there was this debate about debris and all that. The Americans were very neutral. They never talked directly against the Soviet Union. So all the American satellites like UK and all that, they kept on raising this issue. It became a political issue rather than that. That's one kind of, so it's been around ever since. What has significantly changed now is the fact that the scale of operations has gone up. The huge numbers have gone up. And for the first time in recorded history, I think two satellites collided, a dead Cosmos satellite and an Iridium satellite collided, and it created a lot of debris. Now this is debris apart from the fact that there are a number of rocket stages, upper stages especially, that have left residual propellant. They have also exploded. And if a collision happens between two satellites like Cosmos and all, it creates its own field of debris. Or if a kinetic weapon test like the Chinese did in 2007 at a high altitude, that will also create a debris. So there's a whole string of requirements for debris. The problem with debris and getting it back is the fact that in order to do that, you need to put something very expensive into space, and debris is distributed all over, so it has to do a lot of maneuvers occur. So it's going to be very expensive in order to remove all of that. So the standard solution people do is, in order to eliminate it, for example in geostationary orbit, at the time when the satellite is going to die, right, you have a little bit of propellant and you kick it into something called a graveyard orbit. Okay, so that's the kind of standard thing that we're going. But let me reassure you. So there are going to be many more incidents like the Chinese incident. And now I think China will try to make sure that those incidents don't happen. All of us do it. Once it happens, we will try not to do it. So I think that part is going to, but it will happen. Because these are complex systems, and certainly you will have problems of re-entry. And I'm not sure whether some major disaster will happen or not. If it hits a big city, for example, a big piece, it's going to create a major problem. These things will happen. And I don't know whether anything can be done in order to avoid that, unless there is an international agreement. Okay. Now, all international agreements that we are talking about have been stymied simply because everybody knows what has to be done, but nobody wants to do it. Why? Simply because I have an advantage, I don't want the other person to have the advantage. So let me repeat, international law is about a ratification of a power structure. And as long as there are competing power structures, that ratification will not happen. Let me give you an example. The Outer Space Treaty and the Partial Test Ban Treaty was negotiated when there were two powers, right? One was the Soviet Union, one was US. Other countries didn't have any stake. Okay. So what did they do? For example, the nuclear treaty, right? They had atmospheric tests. Lot of people had problems because of radioactive debris coming out of those atmospheric tests. It created a major health issue. Okay. Then they had an underwater test. They did a nuclear test underwater off an atoll called Johnston Atoll or Johnston Island. They destroyed half the island. Okay. They did a test in space. I think it was called Starfish or something like that, some megaton test. Some 15-20 satellites got destroyed. So the Soviet Union and the US felt, right, that this is bad for both of us. Let's get together and we will have an international treaty. So I'm coming back. Partial Test Ban Treaty and the Outer Space Treaty, which bans all these nuclear tests, came about because these two powers agreed. And once they agreed, right, they forced all the other countries to agree. And what does it mean? So ASAT treaty, for example, if an ASAT treaty is signed, India cannot do an ASAT test. Right? So when they did the, when they did the NPT, right, India had not tested. So obviously, we had a problem. So the point about treaties, therefore, it's about ratification of power structures and legalizing them so that other countries don't have access to the same kinds of things that we have done, right? So it's really about, so it's all about power relations. Treaties are all about marginal exceptions like Antarctic Treaty. We'll talk a little bit about that if required. So this is really the way the world works. So we are looking at power structure. So I do not believe that China and the US are ever going to agree, at least not in the next 10 years, because they are looking, and the Americans believe that they are at a significant advantage. And they do not want the space area to be dominated or even partially dominated. So this competition is going to intensify. We're going to have more problems, right? Some of it will be controlled with improved practices. But I don't see an agreement which limits anything. This is how I see it. So the debris will continue, it will increase, many satellites will get damaged. All these are predictable. Can you do something? There are technical choices that you can do. They are expensive. Will they be implemented? Maybe, maybe not.
Good afternoon, sir. Sir, my questions are very in general, so it is not pointed to anyone in particular. So my first question is, as the need of satellites are very much increasing, so there is a need for ISRO working in a commercial part and for military purposes. So is India taking any steps towards this, like dividing ISRO like for separate for commercial part and dedicating another part to the militarization? So that is my question. I hope you got the question, sir. And my second question is, we have seen our adversaries like China, which are building their own space commands. For example, they have strategic space command dedicated for space. So, is there any need for India also to have a dedicated space command, as all the armed forces are very much dependent on the satellites? And my third question is, we spoke about the ASAT satellite, like ASAT technology to destroy any satellite, but do India have a capability to secure our satellites? Like basically, I feel it comes under the ballistic missile defense. Whether are we capable of securing our own satellites? Thank you, sir.
So let me answer the last question first. In order to defend a satellite against an ASAT test, you need to have a very smart satellite. You need to build a lot of maneuvering capability and all that. You need to be able to send something. So it requires a lot of new development. I would argue that the Americans are already far ahead in doing most of it. So they are looking at it seriously. The moment you do all this, it means you're going to complicate your satellite a lot, because it has to be able to detect everything around it. Has to find out whether something is threatening or not threatening, and then it has to take some. This is one kind of thing. So maneuver is one of the easiest ways in which you can avoid something coming to. That is definitely a possibility. But so the second question that you talked about is ISRO and what it can do. My point would be that the number of satellites that India requires, I don't know whether there is an assessment at a national level where we look at an integrated picture of even in transponders, civilian communication transponders, I think more than 2/3 of the transponders we use in India for television are foreign transponders. Don't have that much capacity. So clearly there is a need even to build domestic capacity for commercial needs. So the industry role in the development of the space program should become an industrial program of the country, not an ISRO program for the country. You understand the difference? ISRO should now move away from a lot of the work that it does internally to creating a space industry. My boss, Professor Dhawan, when I used to work for him, that is what he wanted. He wanted India to become industrially a space, not ISRO as a space. So I think the response to that, if you want to scale up, want to propagate this, you need to make a massive investment with government support to industry, not telling industry here's an opportunity, come and bid. But say we will buy 20 satellites of this kind if you are willing to provide them. Please provide them. We will pay you this kind of money. These kinds of contracts can be worked out. We've done some of it in ISRO in the earlier days. It can be done. So we need a government kind of initiative where the industry is encouraged and motivated to make the investment so that they can produce. This has been talked about for the last 20 years, ever since I left ISRO. It is still talk. ISRO is a monopoly which makes policy, which makes builds satellites, builds rockets. It doesn't want industry to grow in the country, is my view. We need to change that. Who's changing it? No, nobody's changing it. We don't understand what has to be done, or if you understand, we don't want to do it. So industry, in my opinion, is a major requirement, even for the civilian. I think the country is now clear. The Defense Space Agency has been set up. So the civilian part and the military part apparently are like, I would argue there is a lot of economies to be derived if you can put them together. The same satellite bus can do the civilian part to the military part. There is some need to coordinate, whether they should be separate or whether, so that's a political decision. I don't know the current thinking. But there is some sense to trying to make sure that we have an integrated view so that even the industrial part can be taken care of. A lot of defense satellites can also be built in industry. I mean, all the stuff that I talked, L&T or a consortium of companies can build 20 satellites in 2 years. It can be done. So the point I'm arguing is I think we need a national look And right now, I don't see that national. So we have pieces, like everything else, we have pieces that are there. But I would argue that we need to make first, and we need to recognize there is a requirement. Of course, one solution is to tie up with the Americans and say they will give up. I think it's a risky path from my own experience. But maybe that's the path forward. I have no idea. Maybe that's how the future. But this is something that you need to.
Here. Okay. Not answer. Okay. So my question is, can you please share your brief insight on China's hypersonic programs?
I am not an expert, but I think we have some people. Ramani has worked on it, so maybe he is the right guy to talk about it. I think there is hypersonic missiles are going to see. Let me repeat: when a ballistic missile re-enters the atmosphere, it is already at hypersonic speed. It comes into the air of the atmosphere. It's already traveling at. So one of the problems in ballistic missile defense, for example, is the fact that it's very difficult to predict. You can do a few things in order to make it move. So it's very difficult to deal with a very fast moving. And if there are several of them coming back at the same time, the defenses are, it's, all this BMD stuff there. So even ballistic missile defense, for example, is complicated. It's not going to work time, as well as people say, although we assume that it's going to. This is one part. The hypersonic is different in the sense that it doesn't come from space. In the sense it comes from a regular missile going up. At some stage in the missile's thing, kind of goes above the atmosphere, because to do it at the atmospheric level, then it is able to maneuver at hypersonic. And it can do a number of these alternative trajectories. Again, it complicates the thing. So the difference between a hypersonic trajectory and a ballistic missile trajectory is the time. Hypersonic may be much shorter. Typical ICBM, for example, you have half an hour. Hypersonic missile over a shorter range, it may be the order of a few. So it complicates the defense. Now the Chinese are doing something, the Americans are doing something, Russians are doing something. I'm sure India is also doing something. And I think all of them are going to get into the operation. And I would argue that it is going to be a very destabilizing. In the sense we already have a complicated situation, likely to be. But are the countries of the world going to agree? My argument is the US may think it's ahead, the Chinese may think US is behind, or we are ahead. So everybody is competing for what I call being the first to be. So at some stage when everybody feels they have enough, maybe they will. As I see it in the entire domain of all this integrated information war that I talked about, I see no easy separation and identifying parts of it. Everybody will have to look. My point is, it is a reality, it will become a reality. He did some trajectory work for hypersonics. Yeah. No, I think stealth is going to be a part of all of them. I think there will be ways to counter it. These are all givens. The point is, we should assume that all these things, then worry about what. Salt is gone long ago, sir. Start 3 is also. I see, the nuclear thing, in my opinion, is more like, see, the Chinese approach to nuclear is interesting. They bring in what is called strategic ambiguity. So the DF-21 missile has got a military component, like a ASPM, has got a nuclear component, where a nuclear weapon is there. The two missiles to a radar is going to look pretty, right? Now the Chinese have brought in, so there are two ways of deterring. One is the American way, which says, if you do something to me, I will destroy you. I'm showing you all the things that I can do. You do the tests, you do some interception, you do an ASAT test, or you destroy something in space. So you are establishing credibility by the fact that you are actually demonstrating that I can take you out. In other words, it's hard indication of intention and capability that they're doing as a part of the game. So don't mess with us, we can do this to you. Chinese are smarter. They don't have such a big nuclear arsenal. They're not interested in looking at the whole world and destroying all of it. They just want to deter nuclear attack. Their strategy is to confuse. So my point is, if you introduce an element of risk into a Taiwan crisis, saying the DF-21 that I'm going to use in the crisis, because of all the AI and all the stuff and the complex network that you're doing, there is a faint probability that this missile, that is a civilian or a conventional warhead, can be mistaken for a nuclear warhead and you might respond in kind. So it's a risk you have to take. So they're putting the onus on the Americans to say, please take the risk. You want to go to an escalation of a Taiwan crisis to a nuclear risk, you take that. So they are bringing in intentional strategic ambiguity to this equation. So their approach to deterrence is slightly different. So you have to factor in. But my argument is it's all game playing. I don't think both the Chinese and the Americans will go to nuclear escalation. But as I said, in the escalation possibilities, you cannot rule it out. I think both countries are pretty sensible. Nuclear war is highly unlikely. Huh? Oh, Chinese. Chinese have one for a long time, 1981 or so. All nuclear, all nuclear, all nuclear.
Sir, I have a question.
All nuclear, all of them are there. Yeah, please.
Hello, sir. My name is Shanmita, and I'm coming from the Department of International Studies from Women's Christian College. So this is a question out of curiosity. Even though your software is at its nascent stage, how long did it take to develop this software?
You should ask Dr. Raman.
Yes, sir.
Yes, I think the project that we had with Boeing. Boeing had extensive simulation capability. What they lacked, an orbital prediction model. We all know that an orbital model can be constructed provided the initial orbital position is given at a certain epoch. So they approached us, they couldn't do it, they approached ISSP at NIAS. One of our engineers who was coordinating with them was able to get the NORAD element by looking at the database. And that's what he gave for the number of satellites they needed. I came in at that time and said, I'm a lazy man, I can't sit down and write the piece of paper, but I prefer to write a program for getting it from the NORAD data. That took much longer. I will come to the finally answering the question of how long did it take. You should also appreciate I am a pretty old person. So as a result, my knowledge also is centered around Fortran, one of the archaic languages. So if you are doing it today, for example, I can answer that way. We have learned a lot of things in the past. Maybe at some points in time, we needed a lot of help. So, but now possibly if somebody is willing to do this in a language like C++ and a core level code for fetching the information from the NORAD database can be in Python. It can be done fairly in the entire trajectory can be computed in less than 6 months. The GUI is over and above that. This is a fairly well-known one. We took a lot of burden on us in terms of the old language was being used, which is Fortran, which is not ANSI compatible at that time. So as a result, many restrictions came on the computing program before it drives the GUI. So the GUI program cannot accept from a Fortran a single element. It has to be only a string elements and things like this. These are the kind of unrealistic limitations on the handshake part of it. Without any of those, if you move into modern languages, it's possible 6 months. You still, how long did it take? And by doing this, I have become old.
Thank you for answering, sir.
And one of the reasons I've hesitated to get into the Indian thing at all. See, first, I don't think I'm competent. I'm good at the strategic part. I'm not sure I understand the tactical part. And I really don't have enough knowledge about the tactical aspect of war fighting. I have to confess I'm totally ignorant. You have in C3S a very august body who know much more than I will ever do about that part. So I never have done any work because I see a lot of sensitivities in the Indian thing. For example, NIAS is a kind of think tank, but I can't afford to go out and say that India is doing this or not doing it. I would argue there is a limitation which we put on ourselves. That is one part. The second part I would argue is that we are. I would argue. I mean, the only thing I did was to do something on space because I felt that when I did the China study, I felt everybody would ask about what India should do. That's why I went and did that part. So I generally don't worry too much about what India does. Don't worry about India's national security, really. And I think that's largely one of the reasons I think the program we have evolved is more to look at the neighborhood and what kinds of challenges it poses for them. And so this is one of the reasons why I think I am not in a position where I can clearly answer your question. And I'm certainly not privy to the secrets of the government of India to give you this authoritative discourse of what India is doing or not doing. I don't know. So that's really the answer there.
Sir, and I have another question for Professor Raman. Sir, how robust is this satellite simulation software? Is there any possibilities for a cyber manipulation?
Sorry.
See, as we said, this is useful for many defense organizations. So they don't want to get connected to internet. That itself gives a lot of immunity towards a cyber attack. Cyber attack in the other forms, where, for example, supply chain management, etc., is independent of connectivity to internet. That everybody should take care, right? Given that, there is no possibility that this software can be attacked by, it doesn't have a extra threat as long as the minimal adherence is, for example, if you, in the name of, it's not such a crucial thing, first of all, for somebody to come and attack in the cyber thing, okay? Given that if somebody is determined to do it just for a demonstration, well, you try your best, if you can't, let it go. So that's another. See, but to come to the serious thing, was there another part of your question other than cyber attacks? So what I can say is, I thought first, right, the way I understood to begin with, how did you know that your program is doing the right thing? So that's what I thought you are going to ask. See, there are a number of test cases which are published by NORAD itself for a certain number of NORAD given elements from this time to this time. You can compute it and compare with that, right? These are machine readable files. You can even make a comparison machine logic wise. You don't need to sit and check someone reading, someone else checking, etc. So this process can be made automatic. So that is as far as the trajectory is concerned. The rest of the things, I depend on solely Chandra. So what he is one of our major users. So whenever he does, I can recall many cases where what do? We take some algorithms for whatever is the thing. For example, this is all, what happens is, intersection of polygons is what it ultimately comes to. These are very standard formulations are available. You code them and the test cases are there. But when you integrate, there can be problem. But let me add more to that. When we used to be in ISRO, when we were really developing software for critical applications, it was never done by a small group of people. We had, including inversion programming, that is, two groups will do the same problem using different approaches, that means different coding techniques, right? So as under the thing, they are not going to exactly match for various reasons. but qualitatively if they match, and analytically one can have, at least you end up giving credentials to them in the sense which is number one, which is number two, right? So we order them by saying that this is what, as long as it gives the result, this will be number one. If it has any convergence problems and it is unable to produce a result, then you fall back onto the second software. That means we have, first of all, we need a result. If you get results by more than one way, you have a priority as to which is number one, which is number two. That's the way the inversion program. Now, not only that. So, for example, if the software is working and some modification is necessary or some bug is identified, you have to make through the code changes have to be performed. This code changes can fix this bug, it can introduce bug elsewhere. So this is a very tricky situation where generally these days you have the so-called IDEs, interactive development environments, which can even generate the test cases based on the coverage that you need to do. And over and above all this, review is the only process by which it can be done. More than one mind should come in. We are not talking about such a critical application. So I thought your first question was, how do you prove the program right? So is it? Yeah, cyber ambiguity.
My questions to Professor Chandrashekar.
So my question is to Professor Ramurthy. Sir, can you give more insights on the business incubation model in China for the science and technology field?
See, business incubation model is a well-known model, extensively used in United States. Is it okay? Yeah. What they do is, you have an institution, a setup, which gives the basic facilities. You have an idea, you go to them, they first screen whether the idea is workable, can it be implemented. Then they give you basic support to actually implement it and show that it works. And then they give you some infrastructural support so that it gets started. Once it is picking up, you go out and the next person comes in. This is a well-known model. Even India has it, but they have many more such. So, lot more students will have an opportunity to try out their idea. So, you see, even if you just see internet, many of the small things are all originating in China because of this. Because you can try something, if it fails, you go. I always say, in the United States, I have an idea, I take money from one of these institutions, it fails, and I will fill it in my CV that I had an idea and failed, and I am ready for the next idea. In India, I have an idea, I fail, even my wife will not cook for the next meal. That is a cultural difference. China has gone on to the US model. You are welcome to fail, but try.
My questions to Professor S. Chandrashekar. Sir, I want to ask you about India's space program with regards China's space program. So, China, Long March 5 and all these rockets, they've been able to, venture out into the heavy class, although not super heavy traditionally, but heavy class they're able to venture into. What's stopping us at only taking to 4 tons to geosynchronous transfer orbit? And where is the lacuna? That is, we have a cryogenic engine, but there's a lot of talk about semi-cryo, etc. Where is the lacuna? Where did it start? Do you think that ISRO spy case or something had something to do with it, or is that just...
So first let me...
Yeah, I watched the film, but no, that's not part of what I'm asking. I'm asking this because... Yeah.
Yeah, let me answer the first question. I want to say the ISRO spy scandal had nothing to do with what happened. Okay. The spy scandal is a reality,
yes,
but rocketry depicts that reality not necessarily in the real world that it happened.
Right.
I can speak with authority because I was one of the people who actually wrote a letter along with Professor Dhawan in support of Nambi and why he needed to be defended. So there is a lot of issues behind the spy scandal, but rocketry depicts them in a very different light. So first is forget about the rocketry part. The spy scandal, I mean the cryo spy scandal is true. Yeah. A lot of it is just created. And a lot of it is not external, as everybody makes it out. It's not the CIA, it's not the State Department. ISRO knew very well when they signed the cryogenic deal that the Americans were going to sanction us. One of the reasons why I left ISRO was because I said we should not do this without understanding the implications. So I left ISRO because of that. So my point again is, it is not as though people who took the decision to get the Russian cryo did not know the consequences and what the Americans would do. They were very clear that they were going to follow the law, and the law was very clear that whether the president wanted it or not, sanctions would be imposed on ISRO. So that's the reality. So the American hand and all that stuff that is projected in a lot of stories and all that is absolutely untrue. Okay? There is absolutely no basis in reality or fact. Nambi had a serious problem because he was a victim, and he went to jail, he suffered a lot, and he's come out of it with flying colors. So what happened to him and all those problems associated with it are genuine problems. But all the other stuff that went into it about the cryo, about who did it, who didn't do it, a lot of it is, I think, creative cinematic license. We should give that part to the but please don't believe a lot of that part. Yeah. But what happened to Nambi and all that is genuine, and I think it reflects more on the internal systems we have in place for the governance of some of the critical areas in our. I don't think that lesson has percolated even now, so we still may be somewhat similar in a lot of it. So one is, it was injustice that happened to, I would argue that Nambi was one of several hundreds of scientists who contributed to this. All of us did it, but so the point is, he had this particular problem, and because of that, I would argue that what happened to him shouldn't happen to anybody else. That is one part. The second part you wanted to know was what, please?
So with regards heavy lift capability, we are stuck
you
at
wanted
4 tons.
about the launch cap. Yeah. Why is it? Yeah. I would argue that signing the cryogenic engine deal set back the Indian program in a significant way. Now, why am I saying that? Let me argue that. My argument is, if the Russian technology had come, so let me give you the earlier example of the technology import. We got the Vikas engine technology from the French, which actually powered the PSLV. I was directly involved in ISRO when all this was happening. Okay, so I'm talking with a reasonable amount of knowledge. It takes about, I would argue, 7 to 8 years to take the technology and to be able to actually convert it into an industrial case. It requires a lot of investment. Okay? And we can certainly produce an engine. But a liquid rocket engine is much more than just the production part. You also have to know a little bit about the design, about the thinking behind it. It's a highly complex interconnected system. Everything affects everything. So you need a lot of what I call knowledge generated by actually doing things. So only when you build and launch them and understand them properly can you really, right? So when Professor Dhawan left ISRO in 1984, he had already thought about the next step, which is to go from PSLV to the geosynchronous launch vehicle, which is powered by the cryogenic engine. He wanted one engine, cryogenic engine. So we had identified the cryo upper stage as critical. I think it was the right choice at that time. And he said, we will do that. Professor Dhawan had understood MTCR. He understood what the Americans would do. He had come to the conclusion that we must do it internally, in the country. And he said, we will do one cryogenic stage, which will be added to the PSLV modules, right, in order to go into the GSM. Okay, so this was the plan. He retired in 1984. Now, successive chairman after that went back, and legitimately so, to relook at it. So there was also this strong lobby inside ISRO which wanted an import, because they had done the Vikas import, and it had fired the PSLV second stage. So Nambi, for example, was a part of that group which wanted the import. So what happened is, so like all people, we wanted to examine whether people would sell it. Right? The Americans, so we went to GE, US State Department. So we went to the Americans and asked them whether they would sell us. Now the Americans have a very good Atlas Center upper stage, fantastic cryogenic engine. If they would give it to us, nothing like it. And we could actually do the JSLV and kind of jump ahead of the curve that we were looking at. Unfortunately, the Americans have had serious problems always with the missile part of ISRO. They don't have so much problems with satellite parts.
So, but cryogenics aren't used in missile, right?
Let me come back. So the MTCR, right, which is what I'm talking about, does not separate out what is cryo, what is not. They have a requirement. What is that requirement? Any satellite, any rocket stage that can take a 500 kilogram payload beyond the range of 300 kilometers is subject to MTCR sanctions. MTCR became a law in the United States. Okay, and if you violated the law, the Congress would sanction that particular entity. So that was the case. So then what happened? Because of all this, right? We could. The Americans said no. The other country that had the stage was Japan. So we went to Japan. Japan didn't even look at us. I think they are more American than the Americans. Okay, they didn't even look at us. I mean, I'm talking because I knew all this. I was there. Okay. And then the third option was to go to the French. They had an upper stage for the Ariane, which was doing very well. So when we went to the French, they said in those days they wanted a price of $2 billion. And they put all kinds of conditions on what you can do with that stage. Okay. We didn't have that money. I don't think the government is going to give us that kind of money. So we had to say no. So we went back to the indigenous option, and we had actually got the project cleared for an indigenous cryo with a GSLV with an indigenous cryo. It had been approved at the cabinet, and we were going to go ahead. I'm talking about 1991. So between 84 and 91, we went through all these stages. But I think we should have gone ahead and moved on the cryo on ourselves. So this was one part. We did make some investments, but maybe not enough. So that was one part. So when we went to when all this was happening, the Russians suddenly came up and said, we have this cryo stage. Now let me repeat, the cryo stage that the Russians had is a fantastic stage. Very good. Very good. But there are two problems with it, right? Now, as we were talking during the 7-year period, what is happening to the requirement? The communication satellites have been growing in size. So the GSLV has to deliver a communication satellite which has to be built in the future, because it's going to take 5 to 8 years to build, and therefore you have to project what the satellite weight is going to be in the next 7 to 8 years. So we were doing that exercise, but unfortunately the Russian cryo, even with all the things that it promised, was going to fall a little short. Okay. But then ISRO took the view, I mean internally it was one of the views, that we would go ahead and sign it because it was a very good deal. For 250 crores which promised, they said we will give you everything. And then we went ahead and signed the deal. So the moment we signed the deal, the Americans caught on. Right? They had a deal going $2 billion worth of exchanges between Russia and the United States. They turned the screws on the Russians, and within a year they had to renege on the contract. Now what happened to ISRO? We have to do the Russian stage. We have, for political reasons, we had to go with the Russians. So we had the Russian stage. 7 of them came to us. We put them on different components and do some launching. So that's one project. The second project was to reverse engineer what the Russians had given with Indian industry. That's the second project. And the third project was, as it was going on, we need a higher weight for the satellite. We need to do a third indigenous cryo development. So instead of doing one project, which is what I think we would have taken longer a little bit, maybe spent a little bit more money, but then we ended up by doing 3 projects, which took even longer. At the end of it, we didn't even get the capability. So the cryogenic engine and its development has delayed ISRO significantly. So one of the reasons why we are only at 6 tons, the Chinese are at, but even low Earth orbit, assuming GTO, low Earth orbit, you just launch at whatever you want, we are looking at 5 tons, 5, 6. So the point I'm making is everybody else, the Chinese have gone far about 25 tons is I think CZ5. If you're looking at US, Elon Musk is sending a Tesla car to Mars, and he's building a bigger rocket. So everywhere, I think the Americans have 3 or 4 big rockets. The Europeans have at least 1. The Chinese have CZ5, which is big. Everywhere else, they are far ahead. Okay, so we are still behind. Now we have to do, the next step we have to do is to build a bigger rocket. Have to do that. Whether we have the money, how we will do it, these are all only ISRO can answer. I can only talk from.
Thank you, audience, for asking very pertinent questions, and thank you, panelists, for taking out time and answering all the questions very patiently. This is an announcement to know that we have the discount coupons for the book. Those who wish to purchase the book, kindly contact the organizers. Now, as we have come to the conclusion, I invite Dhanya, Research Officer C3S, to propose a vote of thanks.
Good evening to one and all present here. I am Dhanya, Research Officer at C3S. I thank C3S for giving me this opportunity to propose a vote of thanks. I thank Rear Admiral S. Venkat Raman, BSM, Flag Officer Commanding, Tamil Nadu and Puducherry Naval Area, for taking time off his busy schedule and graciously agreeing to release the book today. I thank Professor S. Chandrashekar for giving us the privilege and opportunity to launch his book in Chennai and for the insightful presentation on China's A to AD strategy. I thank Professor V.S. Ramamurthy for his riveting presentation on China's emergence as a global power in S&T and innovation. I would also like to thank Dr. N. Ramani for his presentation on software for missile trajectory and gracing us with his presence. I extend my gratitude to all the veterans from the armed forces, serving officers, foreign delegates, distinguished members of C3S, and friends from the media for joining us in this event. Last but not the least, I thank the students and the audience who have joined us virtually for your participation, interactions, and bringing useful discussion to the table. Finally, I would like to thank Chennai Center for China Studies and Commodore R.S. Vasan for giving us this opportunity. Jai Hind, thank you. And I request everyone to have refreshments which is served outside before leaving. Thank you.